Sorry, I hit enter by accident. So we're starting the stream 15 minutes early because I pinged everyone. Yeah. Hopefully it's not choppy today. I didn't get a chance to worry about the choppiness and fix that. I had too many things to do, but I hope it's not choppy today. Welcome to the first viewer who has come to the stream early. It says that it is choppy. Very cool. I think I may have too many things open. Okay, for the person, oh, Ren, you're here? Welcome, Ren. It seems good? Okay. So many things. The worst part about streaming is not even anything to do with viewership or anything like that. It's that there's so many statistics going on all the time. Hello, Malrog. There's so many statistics going on all the time, and most of the statistics are saying like everything is broken. And I'm like, everything's broken. But no. It's not actually broken. It's just maybe a little bit broken. I'm not sure. You really not assuming enough video. Huh. It's a weird error. It says YouTube is not receiving enough video to maintain smooth streaming. What does that even mean? Enough video? Like what is the amount of video? I mean, I guess like frames, but is it choppy or is it not choppy? Maybe I'll reload the control center and see how it goes here. Not choppy. It's not choppy for you. Your upload bitrate to YouTube must be low. It's not low. It's at 3,000. So maybe I'll just increase it. Let's do 5,000. Better? Same? Exact same? I don't know. Okay, we'll roll the punches. If it turns into choppiness, then maybe we'll have a shorter stream, or maybe a more sort of a tech stream. Okay, so over 9,000. No difference. Okay, interesting. So in this puzzle, Color Mask by Olima, the white dots indicate consecutive digits. and it says that red cells are column indexing. Green cells are row indexing, which we'll come to what that means in a second. Digits in a cage do not repeat. Okay, so that's impossible anyways, because there's no cages that are outside of a region. No digits could repeat in the cage anyways. If a cage total is even, so it sums to an even total. So for example, like if this is a 2, that's an even total. But if this is a 3 and a 5, that's also an even total. Ignore the white dot. Because that is 3 plus 5 is even. It's 8. And oh, I see. So otherwise all cells are green. So if it's odd, like 1 and 2 is an odd total, that means that it's green, but it says otherwise cells are green. Anyways, that's what that means. Red cells, so if this was an even cage total, then it would be red, and then it would index things in the column. What does indexing the column mean? That means in this row, the second row, this cell would index the 2. So that would mean that in this column, that the 2 would go in the third cell from the top in this column for this row, which is 2, and this cage, which is red. Very confusing, a little bit confusing. If this is green, on the other hand, and this is a 3, then you come from this side, you look at the third column, and you say that this has to be not a 2, because this is now the 7th column, so this would be a 7. So a little bit confusing. If anyone needs help understanding the rules while we're going, just please say so. I'll go over them again. But yeah, so red is column and even. Red is column and even. Red is column and even. That's what I need to get in my head. Okay, so let's get going. So first of all, we know that a white dot inside of a box means that that box's total is odd, because if you have 2 consecutive digits, one of the digits will be x and the other digit will be x plus or minus 1. So that will be, together they add to 2x plus or minus 1, which is always odd. Just do that with any number and it will be odd. 2x plus or minus 1 is always odd. So then that means that these are both odd, therefore they are green cages, and they index in the row. Oh, I think I got the red and green mixed up. So it's actually the opposite of what I said. So if it's a red cell, then it indexes the column that it's in, and if it's a green cell, it indexes the row that it's in. So just take what I said and flip it on its head the other way around. So if I put a 3 here, that would say that there is a 2 here. Just like I did with the red example, but I did it the other way around by accident. Yes, I did. Absolutely, I did. That is my bad. Okay. So we know that these are all indexing the rows, and those are indexing the positions of the 2 in the rows. Okay, it says that the stream is excellent connection now. Yeah, because it wasn't confusing enough, I had to explain it backwards, right? I'm sorry. Okay, so the weird part about this is that since these index the 2, if this was a digit which is 1, 2, or 3, right? If I put this as a 1, this is going to be a 2, and then this can't be a 2 for multiple reasons. One, because there's a 2 in the box, but secondly, for a different reason which is more interesting. So if this was a 5, right? Then this would be a 2, but this has to be consecutive with 5, which would put a 2 in one of these 2 cells. This comes back to the sort of secret of indexing puzzles, that you have to have one. So in normal indexing puzzles, there's like in 159 puzzles, there's like 3 columns which you have indexing for, and in these cells you'll have to have one that's high, one that's medium, and one that's low, because there is going to be a 1 in this box, there's going to be a 1 in this box, and there's going to be a 1 in this box. So one of these has to be indexing the 1 in this box, which means it has to be from 4, 5, 6. One of them has to be indexing the 1 in this box, so it has to be from 7, 8, 9. And one of them has to be indexing the 1 from this box, which has to be 1, 2, or 3. So similarly here, we can't have a 5, 6 pair, or a 7, 8 pair, or an 8, 9 pair. It has to be 1 from one set of high, low, or mid, and 1 from the another set of high, low, mid. And the same thing happens here. So the only options we have here are to look at these two cells, these two cells, or these two cells, well, these two cells, or these two cells, or these two cells, or these two cells. So that means that we have very limited options. It's going to be 3, 4, indexing 2's in here, or it's going to be 6, 7, indexing 2's in here. And that's the same for over here as well, 3, 4, 6, 7, which means that there's actually, yeah, there's, so in these columns, these 4 columns, the 2's are in these cells, right? Which means that in these 4 rows, we have a, what is that called? That's called a jellyfish on 2's, because we're going to put 4 2's in these 4 rows, but in the other 4 columns, in column 2, in column 3, in column 7, and column 8, we have 4 2's. So in these 4 rows, we already have our 4 2's. They're in those positions. So there are no 2's in any of these places. Notably, oh, sorry, I did the wrong cells here. These positions. So there's no 2 in here, which is kind of interesting. I'm actually going to highlight a bunch of that because I want to remember that there's no 2's in these cells. I'm just going to do a light gray so that we can sort of, yeah, an envious fish. A fat X-wing. That a pH fat X-wing, yes. So I think this is a little bit interesting, but also I want to look at these 2 cells because these 2 cells are, if it was 6, 7, then they could be 8 or 5. If it was 3, 4, then they would be either 5, which we already have, or 2. So there's 100% of 5 in here? No, it could be 2, 8. Could be 2, 8. But that's kind of interesting for this, actually. Because this can't have a 2 in it. So the options for this run of 3 cells is limited to those options. So 3 to 9, because it can't have a 2. But I'm wondering if it doesn't have a 5 in it, then it's exactly 7, 8, 9. So this could never be 5, 8. So the 9 is placed in the row? Why is the 9 placed? Okay. Well, these cells are from 2, 5, 8, 1, or 9. And 1 and 9 are definitely in these extreme cells. Now, I think what we should think about is not the just general values of this, but no worries, no worries. What parity will this be? If this is 7, 8, 9, that's 2 odd digits and 1 even digit, so it will be even. So then it would index the row, and then it would put 4, 5, and 6 in here. You can't have 4, 5. Okay, this is kind of a, I don't know if this is how you solve this puzzle, but what I have noticed is that if there is a 5 in here, right, which it seems very constrained if there's not a 5 in there, so I'm curious if there is a 5 in there. So if there's a 5 in here, oh no, this could have a 6 still. Yeah, it could have a 6. Never mind. Never mind. That is not going to be good. Hello, Doomdiant. Welcome. Welcome to the stream. We're solving Color Mask by Olima. Or trying to solve Color Mask by Olima. Maybe we should think about these 2s that are overlapping with cages. So if this was a 2, it would be even, so it would be column indexing, which means that it's just indexing itself. If this is a 2, then it would be column indexing, so this would be a 3, which is good because it's consecutive with 2. If this is a 2, it's column indexing, which means that this is a 7. Okay, if this is a 2, it's column indexing, which means that this is an 8. Okay. So that's not useful. I guess 2 in this box is in these 3 cells. I didn't even think about that. If 2 was here, this would be a 5, which would be indexing its column, or its row, so it would just be in self-indexing. Try those cages with 1s. Ah, that can't be a 1, right? Because that would, wait, 1 is odd. So it's green. So it puts a 6 here. And then that would put a 2 here, but that would require a 6 here, doesn't it? I don't know about this. This is kind of like confusing. If we have rule, like I can see 1 can't go here after quite a few little steps, but is that helpful? Really? I was hoping to eliminate like 2 from one of these cells so that we could eliminate like a 6 or a 7 eliminated here would give you that there's no 8 in this cell, which might be interesting. Not that interesting, I guess. So maybe we should focus on other things. So let's think about hello, Olima, creator of this puzzle. Okay, well, if this has a 9 in it, then it's broken. Like I saw that before, but I was thinking about another reason why it would have to have a 9 in it. But if this is 7, 8, 9, then this will be 4, 5, 6, and this can't be 4, 4, 6, or, well, this can't be 4 or 6, and then it has to be 3, 7, and those aren't consecutive. So there's definitely no 9 in here. Row through is 7, 8, 9. Yeah, we just got that. How's the latency, by the way? I was just wondering if you could eliminate 2 from cells adjacent to those cages that... Oh, maybe, yeah, maybe. That would be interesting. So maybe you're saying that... So that if this was a 1, this would be a 6, but then this would be a 2, and this would also have to be a 6. So then maybe if this is a 3, then this also has to be a 6, right? But couldn't this be 4 then? Oh, but then you're saying that 2 can't go here ever. Ah, interesting. Okay, so this can't be 6. Slash hand. No worries, no worries. So presumably the same thing happens over here. So that can't be a 2, so this can't be a 6, right? And presumably the same thing happens with these two, maybe? If those are 1 or 3, those would put a 7 in one of those two cells. Well, if this was a 2, this would be a 1 or a 3, which would put 7 in one of these two cells, but the 7 would be here. So this can't be a 2 either. I see. So that's not actually... Oh, the other way to see that is there's no 6 here, so there's no 7 here. There's no 6 here, so there's no 7 here, which we could have done a much easier way. Okay. So I need to stop saying two words that I want you guys to shout at me if I say is and like, because I was watching back the stream. I was watching back the stream and I kept saying and like, and I was getting really annoyed with myself. So if I say those two words, please shout at me. But now we know that in one of these two instances where the 6 and 7 appear, the 2 is in these two cells. Like, whether it's on this side or that side, one of these two is going to have a 2 in there. This one is kind of boring because that's self-indexing. This one would put a 3 here. This one is less boring because that would put an 8 here, and this 2 would put a 7 here. I mean, not that interesting. Yes. Yes. You understand my pain. Oh, don't say that, Malrog. You're... I could have said nothing and you would have never noticed. It was specifically when I was talking about Fever Dream setting that puzzle, and stop saying but I'm jinxing myself, I swear. But I think that I felt awkward when I was talking about that because it was a sort of weird story, and I said like and a lot of times because it was a weird story. So that's why I feel like I'm saying it on purpose now. And it's just bothering me now. Sorry, okay, back to the puzzle. So here... Maybe it's to do with 1 and 3 because... Yeah, okay. Thank you, Melrog. Appreciate it. Maybe it's to do with 1 and 3. I can't think of why it's to do with 1 and 3, but maybe. So in these cells, there's going to be a 1 or a 3. Well, one of these is like a 1. They don't see each other, so it's hard to describe what is going on. Like they could both be 1 if these were both 2. That's allowed. So I can't say that one of these two is a 1-3 pair. That's not true. And what does it even really do if they are a 1-3 pair? It just eliminates 1 and 3 from here, but we already assume that that's a 2. So that's not very useful. If there is a 5 in here, oh, this is it. This is totally it. So the reason why Olima has eliminated a 6 from here, this is cute. So if there's no 6 here, right, then what is the situation in which we have a 5 here? Well, that's the situation where this is 4-3. But that means that what we never have in these cells is a 2-5, because that would require a 4-3 on both sides. So that means the only scenario where we have a 5 is with an 8. But the only scenario where we have a 2 is with an 8. So there's always an 8 in here. Because well, I guess the other way to see that is there's always a 7 in here, so there's always an 8 in here. This is a warm-up puzzle. This is a warm-up puzzle. I swear. I will do better. This can't be 3 or 7. No, it can't be 3 or 7, because if it is 3 or 7, it will need 2 digits consecutive with 3 or 7 on both sides. And it can't have that. Now, that means that... So if this is 3... So there's only 2 options now. Oh, there's way more than 2 options. There's 3 options. It's either 4, 5, 6. Or it's 3, 4, 5, or it's 5, 6, 7. The color of the run of 3. So in the case where it's 4, 6, and 5, that's 2 even digits and 1 odd digit, so it's an odd total, but the other 2 situations is 2 odd digits and 1 even digit, so it would be an even total. So there's one case where it's an even total, or so there's one case where it's an odd total, and there's 2 cases where it's an even total. I always seem to see things in the negative space as well. Is it worth testing 5 in row 3, column 7, or column 5, which is the only one that makes the cage green? Okay, that's the next thing I was thinking about, is like when it is green, then this is a 5, right? So it's indexing the 3 here. Oh, okay, so this is it. So if this is a 5, right, then this is 4, 6. 4 plus 6 plus 5 is going to be an odd total, because 5 is odd and those are even. But then in this, so then it's indexing the, oh, no, wait, this is green then, isn't it? Yeah, if this is an odd total, then it's green. So it would be indexing the rows. The rows. So I am right. So then, it's so confusing sometimes. So then, if it's indexing the rows, that means it's in row 3. So the 5th row in this column would have to be a 3. But then on these sides of the 3, you would need 1 and 2. Or sorry, you need 3 and 4. Oh, you'd need 2 and 4. This is a warm-up puzzle. You need 2 and 4, but the 2 is not in either of these cells. Three 3s in box 5? Oh, that's the other way to see that, is that it would put 3 3s in box 5. Yeah, because this would be 4, 4, 5, 6, and then the 4 would put a 3 here. Yeah, it would do that. Yeah, you're absolutely right, Jim. Yeah, I was thinking about it way too complicated. Yes, you're absolutely right. So then this is not green, and in fact, this is red. And one of these 2 is a 5, because it's either 5, 6, 7, or 3, 4, 5. So neither of these are 5, so neither of these are 4, so neither of these are 3, which means we can eliminate that one, that one, that one, and that one. Yes, we have this. Now, I don't think we can put 4 or 6 on the ends either, because that would mean that, yeah, we can't start the sequence with 4. It either starts with 3, starts with 7, or starts with 5. Okay, so then if it starts with 3 in this column, then it's putting a 4 here or a 6 here. So there's either a 4 or 6 in one of these two cells, which will marry up with this 4 or 6, giving a 4 or 6 virtual pair in whatever box it's in. And then the 5 will be referring to whatever 4 or 6 is here. So then what will be the 4 or 6 referring to? That will be referring to the position of the 5. Okay. You're now suspicious of the vertical run of 3. Because it's a little bit different because they're all in their own cages. So they all have their own sort of parity rather than a combined parity. But we could probably look at that. This is not a 5 or a 2. No 2s at the end of here. It's definitely a 5 in one of those two cells. I guess we can get rid of 8 from here. But let's look at this now. Yeah, let's look at this now. So these all have their own parity. So either these are both odd or both even. Let's just play with this, thinking about a 2 here. I'm not bifurcating. I'm just trying to think about what this means. So then that means that especially because it's really confusing. No, it's okay. This is probably where we're supposed to look. This is the most. This might be where we're supposed to look too. But so this means that let's keep it microcosm to this chain of 3. We're not looking at this cell or anything. So then this one would say that this is a green cell, so it's row indexing. So the first digit needs to be a 3, which wouldn't work. Oh, a 4. Sorry, a 4, which would work. And then this would be saying that the third value would need to be a 4 or 6, or a 6, I guess. And then this would be saying that in the second column of this row, you're going to get a 5, which is indexing itself. Okay. So I think, okay, so let's go the other way. Let's think about 3, 4, 5. That's saying this would be, oh my God, what am I doing? 3, 4, 5. I was like, something looks off. So that would be saying that in the third row you need a 4, which is impossible, but we can always do that instead, which says that in the third row you'd need a 6, which works. In the 5th row you'd need a 4, which works. And in the 4th column of this row you'd need a 5, which doesn't work. But I'm thinking about more, what does the odd evenness mean for the whole thing? And I don't know. Oh, you're totally right. This is the same parity set. What am I doing? So if this is a 5, oh, bad example. Actually, there really isn't many examples of an odd digit in the middle because 1 obviously doesn't work in the middle. 3 is not going to work in the middle because there's a 2 pencil mark here. 5 doesn't work in the middle because there's 4, 6 pair. So the only odd, and 9 doesn't work in the middle because you can't have 2 digits. So the only odd digit with works is 7. So either this is even or it's 7, which is unexpected. 7 has to have 6 and 8 around it. And then if it doesn't, then it's all going to be odd digits. So let's think about 7 for a second. Because if all these odd digits are ruled out, maybe 7 is the only option. Because if we prove that this middle digit was even, then we would know that it's a 7. Or sorry, if we prove that it isn't even, then we would know that it's a 7. So, but let's think about what it means to be a 7. That would mean that in the 7th column, or in the 7th row of this column, we need a 5. seems reasonable. In the 8th column of this row, or maybe this row, we would need a 5. And in the 6th column of this row or this row, we would need a 5. So in this scenario, we have like 5s, a bunch of 5s. Interesting. That would do a lot. So that's probably what is going to happen, but I don't see a way to like disprove that this is even. So we should maybe look at these cells. I don't even want to like I mean, we've already looked at, say, 2, and it didn't seem like there was anything wrong with putting a 2. So, and we looked at 4 as well, because for some reason I'm doing the same parity again. I'm going to get a drink of water. That's probably why I'm losing my mind. Oh yeah, it's like 25 degrees in my apartment right now. So if I seem like I'm having heat stroke or something, it's more to do with row 3. Okay. Row 3. Oh, right. We didn't really use this, did we? There's a 4, 6. So one of these is a 3 or a 7, right? And that's going to put a 4 or 6 in here. So these digits in here can't be 4 or 6. And they can't be 2, so they're 1, 3, not 5, 7, 8, or 9. And I guess these are from 2, 4, and 6. So whichever... So if I put the 2 here, and the 4 or 6 is over here. But wait. I just noticed something when I did that. If I put the 2 here, then the 4 or 6 is over here, but that's in the 6th position. And the 5... Right, so then the 3 or 7 will be in the 6th position. So this 3 or 7 will be here. And the 5 has to index this one because this can't be... Oh, wait. Yeah, the 5 has to be in the other one. So then what we know now is that this is never a 6 and this is never a 4, because if this was a 4, this would be a 6. And then the 5 would have to go here to index the 6, but the 3 or 7 would also have to go... Wait, that doesn't make any sense. No, wait, that's not true, is it? Oh, wait, sorry. 5, 4, 3, it would have to be then. And that would mean that the 6 would go over here. Oh, so it's actually the other way around. This can never be a 4 and this can never be a 6, because if this was a 6, this would be a 4. And then the 5 would have to index the 4, and the 3 would have to index the 6, but the 6 is over here. I'm not sure if there's an easy way to see that. Rifcon is saying that these red cells are making these consecutive, which I can see that if this is a 2, then this will be a 4, this will be a 6, this will have to be a 5, and this will be a 7. That's not consecutive though. If it was 2, 3, 4, 5, 6, which is one variation of it, then that is consecutive. Oh, doesn't that also mean that this can't be a 7 and this can't be a 3? Yeah, that's true. Is there a good way to see this that I'm missing? A 7 in row 3, column 6 puts 2 6s to the left. Oh yeah, that's a good way of seeing it. So if we put a 7 here, that will put a 6 here, but it'll also put a 6 here. That's a good way of seeing it, yeah. Right, so then at least one other cell. Okay, interesting. Very, very weird sort of situation. I'm not sure it really helps that much. Okay, if this is a 4, then this will be 6, 7. If this is a 2, this will be 3, 4. Yeah, I got that one. Yeah, it's just the mirror implication for sure. So, like, whatever this is determines the parity of this, of course. And now I have to find one more thing. Does it have something to do with the consecutive digits with 2 or something? But these are 4 and 6, so that's not very interesting. If this was like 1 and 3, then it would influence 1 or 3. It would sort of influence this, but 1 and 3, I guess it would need to be. But it can't be, because that doesn't make any sense. um, in the red cells, there's one more thing. I thought we'd eked this dry. One more thing would break the symmetry, so if he says there's one more thing, then there's one more thing that breaks the symmetry, but it seems very symmetric, like 6, 5, 7, 2, 4, 6, 7. I'm not sure I understand. Outside. A little outside, okay. I'm not sure I grasp this one as well as the one from before. So let's think about... Oh, maybe it was... So remember we were looking at these cells indexing cells in the row? Might have to do with that. So if this is a 2, this is an 8. It's being a 2 is that makes this a 7. If this is a 2... No, that's not interesting. Makes that an 8. Whereas this being a 2 is self-referential, this being a 2 makes this a 3. No, it's not interesting. I'm not... there's more to do with this. Like, I am not picking up on what is going on in this puzzle. Clearly. Yeah, I heard that. I was just not sure, like, what else can I even do with this? Is there some kind of king's move that I don't see? Like, if this is a 3, this can't be a 3? Uh, five, 4, 5, 6, 7. Is it the 3, 7? So the other 3, 7. Okay, so this is too hard to think about without putting it in. I'm sorry. So this is 6, this is 2. And then I want to think about the other, so the 7 that's out here is, so it's not, wait. Did I do something wrong, or is this configuration broken? If this is a 2 and this is a 6, doesn't that make both of these 3, 4? Hello, Ambrose. We've just realized something, I think. If this is a 2 and this is a 6, then this is a 4, 3, and this is a 3, 4. Ah, okay. Yeah, I think it's just really hard to see. Yeah. But it's okay, because that also will eliminate the fact that there's a 6 in here, which means that this can't be a 7 because it would need 6 around it. So this is going to be an even digit, which is red. So these are green. So I can start thinking about those after I finish with other things. When I finish with this. Why couldn't this be 8 again? Oh, I highlighted this and take out 8. Yeah, I'm getting there. I'm getting there. I'm getting there. I was noting this before I forgot, is all. So then this 6 is referring to the 5. The 5 is referring to the 6, but the 7 is referring to this cell. That cell has to be the 4 indexed by the 7. So then this cell is going to be 2 because of the 6 in the row. There's no 7 in here. This 4 tells us that this is a 6 and this is a 7. This is an 8. This is a 2. This is a 3. This is a 4. That's a 2. These are not 2s. These are 2s. That's not a 2. Okay, so these 2s say that this is an 8 and this is a 7. This is a 6 or 8. This is a 7 or 9. This 8 is just referring to the 2. I guess we can redden all of these. I guess we haven't used this cell yet. I'm going to get rid of our grays. This cell is saying that the 3 in this row is either in this cell or this cell. Well, this is a 1 or 3, so that's probably where the 3 is. But I don't see a reason why it can't be in this cell. There's probably a reason. There's no 3 over here because of this 3, so there is a 3 over here. 6 in this box is up here. What do we need in this box? We need 1, 9, 4, and one more digit, 3. Okay. We made some good progress there with some help from the constructor. But now what? Isn't that just a 2? Because these 2s look in? I think that's just a 2. maybe we can look at 2s around the grid. There's a 2 in one of these cells. Oh, that's definitely not what I meant to do. 2 down here, and that creates sort of a little pattern on 2s. That's the rest of the 2s. Seems like there's there's 2 4s. There's 3 7s. Yeah, it is a neat rule set. That's why I said, or sorry, I didn't say anything. Olima asked me if I wanted to do another one that he made because I said it was a cool rule set. Okay, so if this is a 4, then this will have to be a 3 down here. If this is a 2, oh wait, this digit, oh, what am I doing? I was literally saying, whatever this digit is, this has to be 3 because it indexes the 6. That's what I was thinking, but my brain did not convey those words. So this indexes the position of 6 in the column, so it has to be in the 3rd position because the 6 is in the 3rd position. So this is not 7 or 9, it's going to be 1 or 5 because it's either 3, 2, 1, or 3, 4, 5. If it's 3, 4, 5, that's just saying that the 4 indexes. Oh, that means that the 4 indexes a 5 here, which wouldn't work because the 5 would be up here. So it can't be 4, 5. So this is 1 and 2. I was going to say it indexes itself in that case, but it does not. So this is 1 and 2, and in fact, this digit can't be 2 because that would need a 1 or 3, and it can't have either one. So this is a 2, and that's a 2. And that means that this is a 1 because this 1 C's up there. This is not 1 or 3 or 9, so it is a 4. There's no 4 or 9 here now, so this is 1, 3. There's no 9 over here. And that's where the trail runs cold. We have all the 2s now. And these digits are 8, 7, and 5. So this is either going to be 7, 9 if this is 8 because of the 7. 8, 6 if this is 7. Oh, wait. There's a 5, 7, 8 triple in the box. So we should use that to realize that this can't be 7 or 8 because it would need 7 or 8 around it. So around the 5, we'll need to put a 4 and a 3, or 4 and a 6. This is a warm-up puzzle. I'm allowed to make 17,000 mistakes. This is a 7, so this is an 8. This is a 7. This is a 6, so this is a 3. That's a 1 because of the 3 here. And this 6 indexes the 3 in the row. This is now in even cage. So, I'm joking, by the way, when I say it's a warm-up puzzle. This is a very nice puzzle. I like it a lot, but I'm just, oh boy. This 5 is indexing itself. It's supposed to be indexing in the row, and it's indexing in column 5, so it is a 5. This 7 is indexing a 5 right there, not right there. That's the 8th column. So now we can think about 3 C's up. Yes, this 3 C's up here. This 1 also sees over here, so that's a 1 and that's a 9. Hello, Sam Oswald, whoever you are. Nice to see you in chat. That's Kagisho, in case anyone doesn't know that I'm messing with him. Now this 5 sees up. It sees that cell. That's a 1. That's a 5. This is a 4, 5 pair. So if this was a 5, it would be indexing in the column and it would be correct. Oh wait, we didn't do this one. This is indexing in the row and it is indexing the 5. So this is this is a, well, this is indexing itself because it's the 5th, yeah, the 5th row in this column. This one has to index the 8 in the row, so that's an 8, which means there's an 8 up here. But I'm gonna, look at this row because there's these two cells in the row, so I want to look at it. I mean, 1, 3, 7, 8, and 9. There's no 7 over here, or 6, but I didn't even mean to put that. So there's no 1 over here, so there's definitely a 1 over here. So can this be a 1? That would mean that this is an 8. Completely possible. That can't be a 6 because there's a 6 below. Box 3 is very interesting. So there's a 1 and a 3 up here. So there's no 1, 3 here. So this is an 8, 9, and this is a 1, 3 pair. Meaning that this 8 sees that cell, which we just said could be an 8. So this can't be a 1, and that places the 1 here. These ones look into here, eliminating all the spots for 1, except for that one. There's a 1 in one of these two cells. This cell is either a 1 or a 3, and it sees a 3, so it's a 1. This one sees up at that cell that we already didn't pencil mark correctly. This is not a 3 anymore. That's not a 7. Oh, this 7 puts a 7 on this side of the box, which means that this cell can't be a 7. So then the only place for 7 in the row is right here. Now we turn our attention to 3 over here is in one of these two cells. Six in this box is down here. Oh, this 6 fixes it. We can actually probably do this column if we look carefully. No, it's only 8 and 9 left. So this cell is going to repeat here, so that's an 8 or 9. 8 or 9. I think row 5, column 2. Why is it red and green? The cage total is not even, so it's not red, right? Okay. Row 8, column 7 is known. Probably. So let's think about that. If it's a 3, then it's saying that in the column, this is a 7. So this is an 8. And a little known fact that 4 is not the same as 8. So this is not a 3. So therefore this is a 3. If this was a 9, then this would be an 8. So this is an 8, which means that this is a 7, which it is. So that's good. That's a 9 now, which means that this is an 8. And these two cells are 3, which is forced to be here, and a 4. That places a 4 here, which places a 4... No, it doesn't. It was close. It's pretty close. Oh, there's also a 5 down here because of these 5s. And that is actually fixed. So that's a 4, that's a 5, that's a 6, that's a 4. So that's a 6. And then in here we need a 7 and a 9. Which is not fixed. Oh, this 8 at the bottom of this column fixes that. That's an 8 now. Yeah, got that now. Over here we have... Oh, this 9 fixes that this is a 7. These two 7s put a 7 here, a 6 here. That means this cell is known it's a 9, that's an 8. This cell should be known it's a 5. That's not a 7 anymore. These two cells are going to be 9 and 6. The 6 here tells us which is the order. So now we have a bunch of cells to fill in. These cells are going to be 6 and something. The 6 here tells me that that's a 6, and then this is a 3. So that's a 3, and this is a 9, which places a 9 here, a 7 here, a 7 here, and this is going to be an 8. Don't you love when you go to say A and then a digit, and then it turns out it starts with a vowel, and you have to say an very quickly? I just love that. I love that so much. Okay, that was a good warm-up. So we have up in the queue, we have Pivot Point by Big Tiger. I'm excited to see what Big Tiger came up with. I really liked when he did those, what is it called? The Marching Army puzzles or something like that. I love those. We have the 9 Archers by KibbyAzure, which is a distinct, so the circles are all distinct values and there's a bunch of arrows. And then we also have, which seems to be the popular choice, Reconstructed Pentominoes by mathpesto. It's a Suguru 0 to 9. I think you can put 0 to 4 or something in each of the regions, and then 5 to 9 in each of the regions. And it's German Whisperers, Region Sunlines, and Renman. And he assures me it's not the one for the coloring challenge, which I did watch. If it is the one for the coloring challenge, then I'm sorry. I have watched the solution. But he assures me it is not. So we have 8 votes and 11 people, it says. So I'll wait just like 1 more minute. See, now it's saying, now YouTube is saying that I have encoding overload. I need to turn down my encoding, my bitrate. But before, when it was lower, it was saying Zeta mask coloring challenge. Before it was saying that my bitrate was too low, so I don't know what to do anymore. Too high, too low. Can't get enough video. Oh no. Why did I wait? Now we're tied. Now we really do need someone to vote. We're actually tied. We're tied for 2 and 3. Oh no. Someone vote or change your vote. I'll have to flip a coin or something. Oh no, we'll be sitting here forever. No! Someone left. So now we only have 9 people. Yeah, let's just, I'll just decide. No, I'm gonna flip a coin. I'll flip a coin or something. Let me get a coin. Heads for 2? Okay, it was tails, so it's Suguru. Whichever was in the queue the longest, yeah, it's Suguru then. Well, I mean, they're both pretty much in the queue at the same amount of time, but here, let me ping mathpesto. Reconstructed Pentominoes on the stream. Okay, now we change to itself. The puzzle itself. We change to the puzzle itself. Okay, there we go. Reconstructed Pentominoes. Okay. All right, let's go. So there's quite a few rules here. Each row and column contains the zero. Yeah, because there's some delay. Oh, just 1 second. Okay, there's some delay. Hello, mathpesto. Welcome. So in each row and column, there is the digits 0 to 9. And every cell. Okay, so literally every cell belongs to. Is this a 10 by 10? Yeah, it is a 10 by 10. I thought it was 11 by 11 for some reason, and I was really confused. Every cell belongs to a 5-cell region, pentomino, which contains the digits 0 to 4 or 5 to 9. No 2 regions of the same shape, including rotations and reflections, share an edge. Okay, interesting. So like pentominoes. A purple line contains a set of non-repeating digits, consecutive digits, in any order. So it's a Renban line. So if you had 0, 1, 2, for example, or 5, 6, 7, but you can't have 4, 5, 6 because, oh wait, they don't actually have to be in the same region. So I guess you could have 4, 5, 6, but they would have to be in, oh, and they can be out of order. So they could be like this, but in this case, these would be part of a pentomino, and then this would be part of a pentomino. I don't know what I just said. That could work. Stop. Adjacent digits on a green line must differ by at least 5. So if, 1 second. Sorry, I need a drink of water. Does 0 only count for low or high? I think it only counts for low. It doesn't say that it counts for 10, so I think it only counts for low. So a German whispers line, or this green line, can be like 1, 6, 0, for example. That could be a fill. 0 counts as 0. That's correct. Each blue line is in at least 2 regions. So this line would have to be in 2 different regions, and the digits within each region sum to the same value. So if these are in 2 different regions, then they of course have to have the same value. That's pretty easy. But if we had a pentomino like this, why do I keep using the same colors as the stuff? And a pentomino, that's not what I meant to do. Pentomino like this, then this digit would have to add up to these 3 digits, like this, for example. Yes, 5 is indeed allowed on a whisper, so it might mess you up. Is that all the lines? Oh, each individual segment sums to a separate total. So if we had a, trying to think where this could work, maybe here, and then we had a thing here, then, oh crap, no, that's not gonna work. We can do this though. Yes, we can do this, and we can do that. So then if this was an 8, then this could be 3, 5, and this could be 1, 7. And since this is a separate segment that enters here and then leaves and then comes back in here, these sum to 8 individually, these different parts of the segment. Hopefully that is clear. All right, so let's get going. I will restart the timer and we will think. Well, first of all, we know these are the same digit. So we know that they both have, so they're from the same set of digits, 0 to 4 or 5 to 9, and they're in different regions. I don't think that's actually very useful. the same thing is true right here and right here. Well, this one might be interesting because there's this line and there's even, so if we say this is in a region and then this is in another region, this one is sort of like a little bit boxing this one in, and then this also boxes it in a little bit because these have to be, there has to be a region split somewhere here. Not that much. Okay, so where do we start here? Maybe we look for the most cluttered area. I guess actually, I didn't really think about this, but the German whisper lines are more interesting than the equal sum lines. Because the German whisper lines, each region only has 0 to 4 or 5 to 9. And the interesting thing about German whispers lines is that if you put like a digit from 0 to 4 in here, then this digit has to be from 5 to 9. Because if you put the lowest digit in here, 0, this has to be at least a 5. So that means that, for example, this digit has to be in a region that's different from these ones. So we can actually give like a little border here. Actually, we can give a border on all the German whisper lines. Anywhere there's a German whisper line, there is a border. Oh my word. So let's add in all of these little borders and see what we think about. Oh, here we can think about a couple things down here right away. Because look at this. This thing has to come out. It can't come here because this one will be the same parity as this and not the same parity as this. So if this was 0, this will have to be high. This will have to be, just ignore the value, just think about parity. And then this will have to be high again. So this one can't come up to here. So that will actually, this blue region has to take that cell. Now this can't be blue. This has to come out. Let's try not to color the high-lowity as much as we can, just for now, because they're pretty short German whisper lines. I'm going to try not to color the high-lowity for now. But if it becomes a problem, I will color it. Yeah, there's a line drawing tool. Yeah. Oh, so can this region come up here? If this region came up here, then this would have to be in a different region because it says in the rules that the blue lines must be in at least 2 regions. So then this digit would have to be the same as these 2 digits, and these 2 digits are in the same region. So if this was a 1, for example, then these would both be 1. That's wrong on so many levels. So this red region cannot come up, it has to come this way. And that means that we can draw a line here. And this red region has to come up again, so we can draw another line. There aren't enough colors for all the regions. Well, no, there's not enough colors for all the regions, but there's enough colors for me to tile it in a way that is readable. This has to come out. This has to be a region, but it could be blue. Then blue would finish like that, because it can't take this cell because that cell is the same as this cell. Now red can't get to this cell, so why don't we color this as like green for now. If it comes over a green line, maybe I'll change it, but this is different from blue, so I'm just gonna note that it's a new color because it's not red, and it can't be yellow, of course. Oh, red can't come up because this and this are the same parity and this is different parity. So red has to come this way, and that makes red complete, that's 5 cells, so we can do that. Now blue can't come all the way up because that would be an L touching an L. But if blue comes up 1, it can't come this way. So if blue came up, if blue didn't take this cell, if we tried to make blue not take this cell, then blue would have to come up into this cell. Then we couldn't come to here because that's the same digit as this one. And we couldn't come here because that's a different parity on the line. So this would have to come up, and it would come up again, and that would be an L shape touching an L shape. And that's region dance. With pentominoes, I don't know if we can call it an N shape. Sorry, an N shape. You're totally right. Totally normal, cat. That's an N, not an L. I would say I'm doing it on purpose just to make you annoyed, but I was totally doing it wrong. Okay, so we get this second region right away. And we know that this cell is the same parity as whatever parity blue is. So this is going to come out. Yeah, why don't... I don't like to turn on the letter tool. Oh, you know what I can do? No, I don't want to do it. I was going to flash like a little 0 in the corner of each one and a little 9 in the corner so I knew which parity it was, but I don't really think I want to do that actually. Green could come here because it is the opposite parity as red, because we know that blue and green are the same parity, and green and red is the opposite parity of blue. So this comes up here. It can only take one of these cells, and it couldn't ever take this cell. So if it came up here, then it would be blocked off from here. It couldn't come to here, so it would have to either take one of those two cells, which is not that great. If it came up here, take one of those two cells, that's also not great. It would actually, wait, if it took this cell, this cell is really interesting. If this cell was in a region that didn't take either of these two cells yet, it would need to take one of those cells, and it would need to not take the other. Because it can't, if you had this cell by itself, and then these two cells in either the same region or a different region, then this digit would repeat in those two cells. Because these would be different segments. Oh, X and O tool, that's a great idea. So let's do X and O tool. I don't know why I didn't think of that. That's a great idea. Thank you, Malrog. Oh, and this is O. So green can also come to here because this is the opposite parity as blue. If green came here, is it like bad? Is that bad? I don't think so. Maybe we should focus on another area. Are any of these other boundaries we've drawn, are those interesting boundaries? I mean, this is kind of weird, but like, I don't know how to even start with this. Maybe this is weird. This region sum line with all these weird boundaries, because there's no boundaries between the region sum line. I don't see it. Okay, so let's continue with, oh, you know what we should do? Let's think about digits. We haven't thought about digits at all, but these three digits, one of them is orange, and two of them are, well, one of them is the X parity, and the other one is the O parity. I don't know what I was trying to say, but so then this digit will have to be sort of on the edge of its parity. So it's either going to be 5 or 4, right? Because if this was 2, 3, or sorry, wait, no. If this was 3, 4, and it escapes to a different parity region, then this will have to be a 5. And if this is 5, 6, then it would have to escape to a different parity region and be a 4. So then this cell is either going to be a 9 or a 0 to map with the 4 and or 5. Oh, this cell is the same as this cell. So that's 3, 4, 5, or 6. So these two cells are the 3, 4, or 5, 6. So these cells are the 0, 2, 1, or the 7, 8, 9. So now this cell is particularly interesting. If this is a, oh, we should have looked at this forever ago. If this is a, if this is a low parity, then these two cells have to add to it, but they're the opposite parity. So this is not a low parity, this is a high parity. So this is 5, 6, this is 7, 8, 9, and these are going to be exactly 3, 4 to give you a 7 here. That's the maximum these can be, and that's the minimum this can be. So that's exactly what they are. This is 5 or 6, so this is 0, 1. 0, 1, 2 here. These could be anything, basically. But they're both low. Or they're both high, sorry, they're both high. This is now a 4 then. This is a 5, 6. This is a 9 now. So these are low digits. So this could be green. If it was green, we'd have to be careful we're not making an F pentomino. Or an N, right? Because it can't even touch diagonally. Oh no, share an edge, it says. Share an edge. 4 on the Renban. Yes, I got that. Oh, this digit is 3 or 4, so this digit is 8 or 9. Oh, this one is 0, 1. Oh, okay, so there can't be a 4 on this line. Oh, is that what you meant, Melrug, or were you saying this one? So there's a 4 over here, so there can't be a 4 on this line. So that means on this line, we need all high digits. So it's going to be 5, 6, 7, and it can't have an 8, 9. So it is exactly 5, 6, 7. Cool. So then these two digits are 0, 1, and 2. So we know that there's a boundary here. We know that there's not a boundary here because if there was a boundary in this cell, then you would need to make either 2 digits add up to 2, or you need to repeat the 2 many times. So this is joined. Could be the same region as that, or it could be a different region. But we know it's from low digits. We know it's not 2, because there's a 2 in that domino. I think we can remove the X's in those. No worries. There's a bit of delay, so like I got this about a second before I saw that on the chat. So no worries if you say something and it happens to be that I already got through it. I know that these two are both low because one of them is joined by this orange region. Now one of them isn't joined by the orange region, but they're both still low. So then this digit can't join with that cell. So this has to come out. And it might join green, I'm not sure. let's get rid of green's mark. This digit is 5, 6, or 8 because it sees 7 and 9, and it is high. This digit is high and it can't be 5 or 6, so it's 7, 8, or 9. Now, the only way this is not high is if this does that, and then a low region comes in here. And that is an L shape, just so we're all clear. That is an L shape, not an N shape. Sorry, I'm being quiet for a second because I don't know where to go. Left of yellow is high? Oh, great spot, great spot. So, Totally Normal Cat says that this digit is high. How does he know that? Well, these two digits around it are both high, and there's boundaries here. So this digit has to be high. If it was low, then it would have no room to escape. So then these digits are low, and this digit is high. Now, is it possible that this digit right here does not join here? Well, if that was the case, then this could be a 1, 3, this could be a 4, and this could be a 4. So maybe it is possible. It's not likely, but it is possible, I think. Oh, this is a little bit interesting right here, this one. Is it possible that this digit is high? Well, if it is high, it can't be 5 or 6, so this couldn't be low if this was high. But this could be, if this was low, this could be high, because this could be 4 or 5. Oh no, you can't do 4 or 5, because then 0 would be on both sides of it, and then there would be 2 zeros in the column. So in fact, these two cells are always the same parity. So then they're the opposite parity of these cells. And the reason why I was thinking about that is what I was thinking, if this cell does not take this cell, then what are its options? It has to go here, here. It is now 3 cells, so it can't join to orange, so it has to go up. But then this cell and this cell would be the same parity, and they're not. So this does not go this way, it actually does take that cell. Could easily take this cell, and then this cell could be a different region, but at least this cell is a different region. The very least is that this cell is either these two are in the same region, or this is purple, or sorry, pink, and then this is a single cell on the line at least. Oh, so this is low, which is a lot of low digits in this row and in this column. We only have one more low digit in this row and column. That's kind of interesting for this set of cells right here, because this set of cells can only now have one low digit on it. So it's very unlikely that these 3 cells are all together. In fact, it's impossible for those cells to be all in one region now. And if either this if either this region comes this way or this region comes this way, then this digit will be low as well. Oh, that is a good point. Well, let's just look at this column in general. We need 5, 6, 7, and then a low digit. Well, that low digit is not going to go on the Renban with a 5, 6, 7. So that is a 0, 1, 2, 3. And that is the last low digit in this column. And this is a 5, 6, 7. So that means that this is a border. And we said that one of these two groups had to join with two things. So this is going to be together. Maybe I'll do blue. And if this thing is together, then it can't join to this because that would be 5 cells already and we have to join them. So that means that if this thing goes up, it has to end like that. Oh, that's cool. So if this goes up, it has to join here, right? That would be orange. But then this digit is now not part of orange and would have to get out, which would do that. But now these two digits, again, share the same parity because they're in the same type of region. And we already discussed that these two have to be the same parity, so these two are different parity. So orange cannot take this cell or it would create the same problem we had before. So that's orange. This is not orange. Now one of these two is low. If this digit is not blue, if it's, say, green or something, then that digit has to come here, right? Now forget about all this. It can't get enough cells, but it's again the same point where orange is pushed this way, and now these two are the same type of cell. So this has to be blue. And again, blue can't come here because that would push orange here. So blue does not come to that cell. Orange, I think, still can come to this cell if purple does not come. Well, if pink comes to this cell, we have the same problem where orange goes up here. So pink does not come to this cell. So is it possible that yellow does not take this only if yellow does this? Which I guess is possible. Oh, wait. If orange takes this cell, right? That's the last cell in orange. That is the last cell in orange. That's 5 cells, so that is the last cell. So this would have to be a new region, which is low. We've already determined that these are the same parity. So this has to be a new region which is low, but it has nowhere to go. This is high. So therefore this is not orange, and this is orange, which means it's a 0, 1, 2, 3. Which means that yellow has to get out through here, that cell, and now yellow can only be one shape because these two can't get to their own region. So yellow is a P. And this is a V, just in case anyone was curious. And now this region has to come out to here at least, and has to get out to here. So that's another 5, 6, 7, 8, or 9. That's not a 5 because that would make 2 zeros. That's not a 7 because there's a 7 in the column. This is a low digit. This is also a low digit. This is a high digit, not a 9 or a 5 or 6. Okay, so then the red region can't come here because that's a low digit, so then the red region finishes just like that. Another N. That creates 5 low digits in this column, or in this row. So these are all high digits. which means that on this line there's all high digits. So there's no way that we cut it like this. Oh no, we could cut it like that if we cut it like that. Ah. There's no we can't cut it like this. Oh no, we can cut it. Ah. I've been tricked twice in the exact same way. Oh my word, that's so embarrassing. Oh, well now purple or pink or whatever you want to call it can't come to this cell. So it has to come either up or down, and if it comes up, then it's only 3 cells because we know this is at least a different region, so that is a new purple cell, pink cell, whatever you want to call it. It looks like the type of thing that would just break for random reasons in the last few cells. Yeah, absolutely. I don't know how he set this. This is really weird. If this was a 4, then these would both be 9. That's not impossible. I was right? Oh. So Sam Oswalt says that if I do this, like I was saying, these two are a minimum sum of 11. So how could you make a single cell sum to 11? That's not possible. So you actually can't cut it there. So that is an X, that is an X, but you have to cut this. You have to cut this somewhere, and the only place to cut it is there. So then this digit, if that was a 4, oh, that would work. No, this can't be, this has to be in the same region as this. What am I saying? So this is a 5, 6, 7, 8, or 9. These are in the same region. Blue? Printing and cutting out pentominoes and laying them over each other. Huh. Very interesting. That sounds fascinating. We are doing things, but if this digit was high, then I think that's broken. Because that means that whether this is low or high, either you're going to have a repeated digit here. If this was the case, then this digit would repeat in the cell below. Or if you had this case and this is a high digit, whether this is low or high, the sum is broken. So in fact, this digit is low. And there's no way that, oh wait, I was going to say there's no way that this is not high, but we can actually cut the line here and then have this be a low digit, and that would be fine. Or the other way to do it, it would be to cut the line here and this be a high digit being the sum of these 3. This has to be the same parity because it can't be 4, 5. So if it's low, if it's high, then it's all the high digits in the row. And if it's low, it's not all the low digits in the row. Huh, okay. If we get one more low digit in the row, then we can say things about this. This is low. We know that. This can't be a 5 because that will put 2 zeros in the same region. This could be 5 though. Well, if these are both 0, then we know that this is a region that these digits are the same. Hello, Tall Cat. Welcome. Now you and Totally Normal Cat can both get mad at me when I accidentally call you the wrong name. Welcome. Oh, maybe we should just do some Sudoku-esque logic. So there's a 7 pencil mark in here, so that means there's no 7 in here. There's no 9 in here because there's a 9 in its region. So then there's a 5 in one of these two. I shouldn't have brought it up. I don't know why I did that. There's definitely a 3 in here. So there's no 3 over here. Oh, where does 4 go in this row? It's right here. No one in chat is helping me. There's so many obvious deductions that I'm missing that are just Sudoku. I'm not upset, by the way. I don't care if you help me or not. This was... Can this have a 0 on it? No way, because that would mean that this has a low digit. But it could have a 1 and a 4. But not a 1 there, because that would be 1 and 3 at most, and that would be only 4. Okay, so more Sudoku, maybe? Don't see more Sudoku to do, unfortunately. This is a low digit. This could still be a high digit if this is the sum of these 3. No, you're not, definitely not totally normal. You're very special, Tallcan. You're our special friend. Our very special friend. And I mean that in the best way. Okay, so in this row, we have 3 high digits. Column, yeah, probably a good idea. In column 7 to 9. So that's these 3. So we only have 1 more high digit in here. So one of these is high and one of these is low. Now we can't make the break here. If we make a break here, then this digit will be the same as this digit, or you'll have a high digit in these 2 cells, and then that can't sum to this one. So that's definitely not a break. So then if it's not a break, then this is the other low digit, and this is the other high digit. I see that it can't be a 7, so it's one of those digits. So these are in the same region. The square below purple, this one, is 7, 8, or 9. If it was, that would be very cool. But there's only 4 digits that are low here, not 5. So don't know if that's true. Is that what you're looking at? Yeah, okay, ignore me, he said. Okay, so this is a break because you can't have high digits in the same region as low digits. So maybe we look at this column now. How many high digits are in here? There's 1, 2, 3, 4 high digits. So there's 1 high digit up here. In here, there's also 4 high digits. So there's 1 high digit. Oh, so this has to be 1 region, and then get out, get its other 2 high digits in these 2 columns, and there's only 1 high digit in each of these columns here. So that actually means that this digit, which cannot connect to these, cannot pick up a high digit over here, because then this one wouldn't get enough high digits. So this is a region which comes over here and does not come over here at all. And the interesting thing about this is that it takes 2 high digits in a row, because it can't take a high digit here and here because these are not connected orthogonally. So what it has to do is not do that, because if it does that, then these two low digits add to the same as two high digits, which is just ridiculous. So, and one of these two cells has to be a high digit, so these two are going to be the rest of this region. And we just got a region out of nowhere. Especially when these are 8 and 9. If this came like this would be 8, 9 equals a single digit number. That's impossible. So these are 8, 9. That's not 8, 9. So this is 5, 6. This can't have 0 on it for the same reason this couldn't have 0 on it. These are all going to be low. What am I doing? These can't have 0 on them, of course. And you know which is 9 because there's a 9 down here. Thank you, Tallcat. So that's an 8, that's a 9. That can't be a 4 now. 4 is in one of these two cells in this column. So blue comes in here and takes 2 cells from here. So, well, 2 cells from here. So then pink takes 3 cells from here, right? So that means that pink does not come into this column at all. Hello, Nordy. I already have a 9. Yep. Oh, you were talking about a different column, but yes, you're talking about this one, right? This 8 also tells us that this is a 7, so this is a 6. So this is a 5, 6, 5. That's not a 5 anymore. There's a 6 in one of these two cells now. Oh, and that's not a 6 because that, so that's an 8, 7, 6. Hello, Kuraban. Nice to see you in chat. Nice to see all these new people. Well, newish people. I think you've been around here a little bit, but newer people. I think everyone's kind of new when you haven't been streaming for very long. Good day. That's not a 7. Hold up. What's wrong? What's wrong? Something's wrong, is what mathpesto seems to say. I'll wait. We're waiting. We're holding up. Oh, you're totally right. Absolutely right. I don't know why, but my brain said that this had to be a 6 because it's next to a 7. It doesn't have to be a 6 because 8 is also consecutive with 7. So, do we get anything? I don't think we get anything. Yeah, I don't think that does anything then. Cool. Yes, I am standing at a standing desk, in case it wasn't clear. See, the reason why I'm standing at a standing desk is one, because it's better for you. It helps your back and your legs to stand at a standing desk, and then I don't have to worry about not exercising and doing Sudoku all day. And 2, the standing desk is the only desk that I have that is actually like pretty large, and I have 2 monitors, so it's the only way I can set up 2 monitors. I would rather not stand at a standing desk for like 3 hours at a time. I usually need to sit down for a little while, but you know, the woes of having a standing desk. But I actually love it. It's really nice. This is 5, 6, or 7, so that's all the high digits in this row. So all of these are low, which means that this is high. Can't be a 5 because that would be double 0. So that's low. This has to come down now because it can't come to the left. And it has to take one of these 2 cells. So that means that one of these 2 cells is high, which means that this cell has to be a 4 because top right. Where? Where is it touching an pentomino? The blue. Oh, so it can't be an pentomino. I thought you were saying 2 pentominoes were touching, and I was like, oh no. But you're saying that this can't do this because that would mean that it's touching an pentomino, and it can't be an pentomino touching an pentomino. So blue can't take that cell, so that has to be pink. So that means that these sum to 10. So this is a 5. Thank you. I don't know why I missed the word blue, but I did. This can't be purple anymore because purple only has 1 cell. One of these is purple and one of these is blue, and they definitely have a 0 in them. I was trying to think if this was a 0, then that would be a 0. And then, oh, this is nice. Oh, no, it's not nice because that's a 0. I was thinking it would rule out all the 0 options from here, but no, it does not. It places a 0 in there. Oh, where did I get this 5? Oh, right, because of this sums to 10 because it can't have a 0 in it because then it would be 0 and a low digit, and that would mean this has to be a low digit, but it can't be a low digit, so it can't have a 0 in it, so it sums to 10. What was I doing over here? There's no 4 over here because this 4 has to be on a line with whatever this digit is, which has to be in the green region, which has to be high. And it can't be 5, so whatever this digit is a 6. I don't know why I said whatever this digit is and then said what the digit was. So this is a 5. And that is a 7 because there's a 6 in the green region already, so this is a 6. Oh, there's 5s looking here, so that's a 5. This is 5, 7, there's a 5 over here, so that's a 7, that's a 5, that's no longer a 7. This 5 looks down here, sees these. Hoping for more of those. But we are straight out of luck. This is 6. Oh, no, this is 8, 9, because there's a 6 in the green region in one of these 2 cells. Actually, oh, I was going to say the green region takes this cell because if it came down here, it would take that cell. But I think it can also, oh no, it can't take the 5 because it already has a 5. So it actually does take this cell. Green always takes this cell and one of these 2 cells, but if green took that one, then this cell would have no partner. It would join nothing. So this is green. Oh yeah, I got that. This is a 6, this is an 8, 9. Oh, that 8, 9 pairs up with that 8, 9, and in fact we have all the high digits in this column, so this is 0, 1, 2, 3, or 4. It's not 4 because there's a 4 right there. Oh, so this is low. No, it was interesting when it was high, right? That was what we were talking about before. Now the square below purple in column 4. Why were those 6s corner marked? Because, Ambrose, because, oh, right. Was that what you're saying to do? Oh, do you want me to go back? So, the reason why the 6s were corner marked was because this is a low digit, right? But one of these digits would be in green because green was right here. So one of these digits is the next digit in green. So that digit is high. But it's on the line of a Renban with a 4. So it needs to be either 5 or 6. but it can't be 5 because there's already a 5 in green, so it's a 6. These are not 6s. Oh, yes, of course, why they weren't filled. Ambrose is pointing out that I could have just filled them in as 6s because they are 6s. I don't know why I corner marked them. I have no explanation. That's not a 6. We have all the high digits in this row, so these are low digits. And there is a 0 in them, because there's no 0 over here. The 0 pointing here tells us that that's not a 0. This region has to get out here because well, this 6 has to get out on a region. There has to be a region up here, which has to take at least those cells. These are consecutive, which means nothing to me. This either takes that cell or that cell. Oh, but this cell can't get out anywhere here, so it has to join blue. Put in some borders. Now this cell has to join blue. And it can't come to here, so it has to come here, and that's a T pentomino, it's a P pentomino. Now, is there a reason this can't be a... No. This is now yellow because it has to come out. These are from 7, 8, 9. So that is all the high digits in this column, right? Yeah, so these digits are low. This is low then. So now we have not all the low digits in this row. So this could still be low or high. But oh, we have all the low digits in this column though. So this is high. It's not 9. The 7 looks down. Yeah, you're right. That's a 6. These are high, I guess. That's not 5 or 6. So now we have all the high digits in this row, so this is low. I missed 0 there, but I don't need 0 because there's a 0 pencil mark there. Now this has to get out. Oh, okay, so if this one took this cell, then these two cells would be isolated. So this is pink. So now this has to come out here. Very cute. Oh, not that. We'll do green. And now this has to come out, but I'm not sure if it's orange or something different. There has to be a border there. That was what I was going to draw before. Now, one of these is high and one of them is low. Do we know what that means? Well, there's one high digit in here, and there's 1, 2, 3, 4 high digits in the column. So one of these is high, and there's all the rest of the high digits in the column. So these digits are going to be low. And they're not 4 because there's a 4 in the column. So that means if they're low, then this digit is high. That's not a 6 because there's a 6 in the column. We're so close to doing something, I think. There's 4 cells here. We don't have 5 cells, so we can't do anything. There's 4 cells here, but there's not 5 cells, so we can't do anything. Although we can note that if this one came down 1, then... Oh, wait. Yeah. If this came down, it can't take this cell because there's already 4 low digits in this column. So if it came down, it would have to take another cell. But it can't take that cell because that would isolate this in a region by itself. So this, whether this comes down or not, must be green. Row 8, column 5 is surrounded by low digits. You're absolutely right. So this is low and this is high. And this is surrounded by low digits except for yellow, so it is yellow. So then this is yellow and that's yellow to finish. Yellow. Which means that this is going to be an 8 or 9. And that mates up with this 8 or 9. It tells us that this is a 5 or 7. And this cell is anything. Oh, I like how Curaban and Ambrose noticed the exact same thing at the exact same time. That's interesting. Tends to happen more than you think. If these 3 cells are in the same region now, they contain a 4, so this could never sum to the same thing, so this has to be yellow. Which means that there's a border here. There's a border here. Let's just draw a border between every high digit and every low digit so that we can visualize everything better. Oh, that was literally it. Okay, so these have to be blue to join to here. Yep. On my screen, Curaban, Ambrose is first, actually. So you better step up your game. Because host advantage tells you that you're actually wrong. If this does not join to this, then it's an F pentomino, and then this has no room for this last digit. So this is orange. Now this could be orange, it could be something else. We only have 1 low digit in this column. So that can't be low or it'd be isolated. So that's high. Can't be 7. Now we have all the high digits in this row, so we already knew this was low. There's 4 low digits in here, so there can only be 1 low digit in here. Now, I'm interested to see if this could be high. Oh, yes, it could be. If it's high, I guess it could do that, right? How many low digits are in here? That's 5 low digits, isn't it? Yeah, it totally is. So this is high. How many low digits are in here? We need 1 low digit in here. And that low digit is going to be here because this region has to be complete. So that's low, and that's red, and that's a region. Something's happening in chat, but I'm regioning. What regions take the cells between orange, green, and blue? Orange, green, and blue? 1 each. Oh, you're totally right. And if they take 1 each, then green takes this one. So that's green. And that's orange because if blue took that one, that's broken. So that's blue. Nice. That's a very nice deduction. Yeah, very cool puzzle, mathpesto. I really like this one. Thank you for recommending it. Feel free, guys, to recommend your own puzzles to me if you want to. I reserve the right to not do them, but I will often do them. So feel free to recommend your own puzzles. Okay, so now this can never be pink. So this is a new region. Let's do this one in pink, and then this one in orange. This can never be pink, so that's going to have to be orange. Now, orange only takes 1 of these 2 cells, so that one's definitely pink, and this is a domino of orange or pink. Okay, now we have to actually do Sudoku. Well, sort of Sudoku. Very disjointed Sudoku. Yes, you recommended your Vault Sudoku. I did put it in the queue. So it is in there. So that's this 4 and this 4. Eliminated 4s from here, putting 4 into here, which eliminated 4 from here, and these 4s already eliminated 4s from the rest of that region, so that's a 4. These are not 4s. That was less exciting than I'd hoped. I think it's fixed now. Tallcat. The 4 in blue is definitely not in these cells because there's a 4 in here and there's going to be a 4 in pink that goes in these cells. So the 4 in blue has to be down here, which means it is that 4. Or I could have just looked in this row and said that's a 4. That's not a 4 anymore. Colors are done, puzzle's over. I don't think mathpesto would appreciate that. Okay, so these cells add up to whatever this is. So that could be almost anything. These cells add up to whatever this is. That could be almost anything. There's definitely a 6 in one of these 3 cells, and those are all on a whisper. So one of these 2 cells is either a 0 or 1. I was hoping that there was no 0 in them, but I just saw that there was a 0 there. Yes, you did. Thank you. I was thinking about whether... Oh, I might be interested in the fountain. Okay. I'll take a look at it if someone sends it to me. Actually, this digit right here can't go in here, so it must go there. So that's a 0 or 2. So there's also a 2 in here. Interesting. This digit goes here, so it can't be a 7. There's a 7 in here, and there's a 7 in here, which means that we should look at these rows and say, oh my word, there's no 7 in any of them, but there already isn't a 7 in any of them. So that was useless. For some reason, there's lines missing down here and over here, so I'm going to add those for my sanity. Malcolm recommends his fountain. Okay, okay. Region sumline with 4 plus x equals 5 in... Oh, I didn't even see this. I literally did not even see that I had placed that. Thank you, Tallcat. So that's a 0. So those are not 0. They have 2, 3, and 1 in them, so this is a 0. So that is not a 0. That's not a 0 either. So the 0 in blue doesn't go in here because that's a 0 for purple. So that is a 0 for blue. This is a 0 for purple. 0, 0, 0, 0, 0, 0. That is not a 0 either. And now we can add in, I was going to say the last boundaries, but we still haven't worked out whether this is a boundary. Well, this is, I mean, this is a boundary, but we don't know which boundaries it bounds in the boundaries. X equals 3. No. No, it does not. Yeah, I understand that. I struggle as well. I just didn't want to, like, color the colors, you know what I mean? I would usually normally just color for high-low, but the colors are colored, yeah. Okay, so we need to work on, so this can't be a 1 because that would need to be a 4. This is a 0, which means that this is a 1, which means this is a 2 and this is a 0. This is a 6, this is a 6, this is a 5. That's a 5, that's a 7, 8 pair. I was hoping to resolve that. Oh my word, that is not a 6. Why is that so hard to write in? That's not an 8, which means this is an 8, and we made a mistake before. Thank you for fixing it, mathpesto. Pink and orange in the middle can't both be F pentominoes. Oh my word, that is so cool. Look at this. If those were the lines, then those would both be F pentominoes, so they're not the lines, this is the line. That's really cool. Oh, this is not 1, so this is 1. Thank you, Ambrose. Now where do we look? Now we might want to look at... We got digits, didn't we? Oh, we got these 6s. So these are not 6s. We got these 5s, which tell us that these are not 5s, so that is a 5. Tells us this is not a 5. That's not a 5. That's important. So that's a 7. That's a 5. That's a 7. That's not a 7. Four, 0 are on the region. Which one? Oh, this one. This one. So these add up to 4. So they have to be a 1, 3. So this is a 2 and this is a 0. This 2 gets rid of 2's from there. No 0 in here anymore. There's no 0 here because of the 0 in the box. So this is the 0 in that column. There's no 0's in here anymore. That's not a 0 either. This 2, that's a 3 then. There's a 3 pointing over here, so this is that. That's 2, 3. 0 in the middle, Y. Yep, got it. 1 looks up in column 9. Oh, 1 looks up in column 9, so that's a 3. So this is a 2, and this is a 1, 4. That's a 3 because of this thing. That 3 and the 3 in this W thingy gets rid of those. That's not a 3 either. There's no 2 in here now. Orange T must have a 2. Oh, the Renban. Yes, yes, yes. I was like, yep. it does have a 2. Yeah, it must have a 2, so the 2 is on the Renban. So this is a 2 because there's a 1, 3 pair in this box now. Scanning. There's no 0 here, and there's a 0 in the column, so that's not a 0. 3, 4 pair in row 10. Is sorted. Oh my, I didn't even read the rest of that. I'm like, yes, there is a 3, 4 pair in row 10. We got that like 60 minutes ago. So that's 3 and 4. This is now a 0, 2 because of this 1. So now 0 and 2 are gone from in here, which it looks like they're already gone by like Sudoku, but you know, sometimes these things happen. These zeros and these zeros are actually lining up, so there's no 0 in there, and that is a 0, which means this has to be a 1. Those are not 1s anymore. That's not a 1, so there is a 1 on here, so that's not a 1, so that is a 1. Which means this is a 2, that's a 1, that's a 4. Is sorted very British. Okay. I didn't know. That's a 0, that's a 2. 4, 3, I have actually consumed quite a bit of British culture, but I think I've heard is sorted before. More than just Cracking the Cryptic, of course. We've all consumed lots of Cracking the Cryptic, I'm sure. Gotta be something with his whispers. Apparently not. What about this? Is this useful now? Oh, this is probably useful. When we have all the digits on this line, we can probably fill in the sum of them. So that's a 7, so then this is a 7. Probably could have limited that earlier, but whatever. This is a 7 now. These are not 7s, which gives us an 8, 9 pair in that box, which places the 6. The 7 in this row places the 8 and the 7. That doesn't resolve this. How convenient. There's no 6 in here, so the 6 is placed right here. So that's not a 6. So if this is a 6, then these are the same digit. That's probably not right. So that's not a 6. And if this is a 9, this has to be 7, 8, which is not going to work. If this is an 8, this has to be 5, 9, which will work. But if this is a 5, these have to be 11, which is not going to work. So if this, so this has to be an 8. So this is a 9, and this is a 5. This is a 9, this is a 5. 2 in the middle orange T is placed. Because there's a 3 here? Probably, yep. So that's not a 2. So then 2 in this column is placed. That's a 2, that's a 3. Oh, also the 2 in purple. Oh, the 4 on the whisper, yes. Okay, so that's a 9, that's a 6, which means this is a 1, this is a 3, this is a 3. That's a 1, this is going to be a 1, 4, 3, 4, 1. And now we just have a bunch of 8s and 9s which are resolved because of this that we already did. That's an 8, that's a 6, that's a 9, that's an 8, that's a 9, that's an 8. That's an 8, that's a 9, that's an 8, that's a 9. This is an 8, and that's a 9. Very nice puzzle. 70 minutes, not too bad. I was being a little bit slow with the whole like, I was just talking to the chat for most of that and letting you guys solve half of it, but you know. Is it choppy? Because I've just looked at my preview and it looks choppy. Very beautiful puzzle, yes. I'm glad he recommended this. Next up, I think we'll do the 9 archers because it was tied. And I think it's only fair if it's tied, we do both. This setter has made a couple puzzles so far. One of them I did the other day, not on the stream, but on the Discord, and it was quite lovely. And then Tier X, I want to say? Tier X? He suggested that I try this 9 archers puzzle. And it looks fun. It is like a unique circle puzzle, so all of these circles have to be different values. And then it's just normal Sudoku rules and normal arrow rules. So, yeah, I mean, shouldn't be too hard, I don't think. I mean, he said it was a high 3. I don't know if I even believe that, because it seems pretty straightforward, at least. Let's see how it is. I'm gonna regret saying that, but let's see how it is. Okay, so I'm just gonna restart, and we can see right away that, of course, if we use all the digits 1 to 9 once each in the circles, then what we'll have to put into here is a 1 for sure. And I was thinking a 2, but we could also put a 2 here if we use double 1 here. Is it the T-Rex? Okay. Oh, this is probably... No. That's a different picture. 3 with some bamboozling. A high 3 with some bamboozling. I'm sure you can make a high 3 with this rule set. But this looks fairly approachable. This is suspicious. So there's definitely a 9 in here and a 9 in here because of the 9s that are given. A 9 in one of those cells down here. Okay, gotcha. I was gonna say, well, I don't know if it's a T-Rex joke, but but I see now that you are the T-Rex. Oh, the T-Rex. It literally says the T-Rex. I always read it as the Tear-X. Now I feel like an idiot. Yeah, maybe. Maybe it's a lower than that. I mean, I'm looking around and I was thinking, given 9s, and 9 can't go on arrows, be probably some easy deductions right away, but I can see now that there is no easy deductions with the 9s. I can make your puzzle solve a high 3 by suggesting logical bamboozles. Maybe don't. Maybe don't do that. Okay, so we need the digits 1 to 9. Okay, so what can this even be? Can't be a 3, can't be a 5, because it's seen by Sudoku. It can't be a 2, so it can be a 4, just barely. Actually, it can't be a 4. It can't be a 4 because if it's a 4, then this is double 1 and this is 2, which means that the 1 is up here, but then there's no 2 in here, so there would have to be a 2 here and double 1 here, and that's not going to work. And I know it looks like a chain, but I saw it in my head because I was already thinking about the 2 being here. This can't be a 4. 6, 7, 8, or 9. Definitely can't be a 4. I also got theater right, which doesn't make sense to me. It doesn't make sense to me either. Oh, maybe it does make sense to me. A little bit. It's close. I would almost think you would get like theta, like the mathematical thing, theta. Anyways, what are we doing? We're doing a puzzle, I think. And this cell can be 3, 4, 5, 6, or 8. This cell can't be 5, 9, or 3, so it has 4, 6, 8, or 7 as options. This can't have a 1 on it, so this is minimum 5, plus 1 is 6. This one, this can't be a 1, 2, because it has the same problem as this, as this one. I did indeed see this. This can't be a 1, 2, because if it was a 1, 2, then the 1 would go here, and this would need to be 2, double 1. Wait, what? That's fine. Why did I think that was wrong? Why did I think that was wrong? This is a 2. Yeah, this could be just a 2, 1, yeah. Okay, so I'm just going insane. So this could be 2, 1. So that's 3. But if this is 2, 1, then this is a 3. So this is still minimum 6, right? Or can this be 1, 3? That's going to be 4. This could now have a 2 in there, so you don't have to put a 2 here now. So this could be 1, 3, and 1. That would be 5. So I think this is minimum 5. And this could be 2, 3 through basically everything. Although 9, interestingly enough, is in one of those 3. Oh no, it could be here. Didn't see that. So maybe this isn't easy. So over here, row 1, column 8, be 5? It can. Because if you do 5, 1, 1, 3, this can be 1. There can be a 2 in here. Can't it? Like, I think that's fine. So maybe we look for where 3 can go, because either 3 is in here or it's in one of these two. I seriously doubt 3 could be here. Because if 3 is here, this is not 1 or 2. Oh, definitely. I had already considered this curve band, but I didn't even like really say it out loud. Nordy getting the bamboozles in early. Did you actually do that on purpose? So what curve band is saying, if this is 1, 2, and 3, this would be 4, 5, and then this would already add to 9, but you'd have to have a digit that is not 0 here, so that wouldn't work. So these can't be 1, 2, and 3, so you're gonna have to put either a 2 or a 3 in one of these two cells. That's the point. So there's definitely a 1 in here. But if this was a 3 and this was a 2, 1, that could still be a 1, I think, right? Row 2, column 7. Why can't it be a 2? Well, if it is a 2, then there has to be a 3 in here, doesn't there? Because this can't be a 3 anymore. So okay, so what we've learned from actually just this is that there's not 1, 2, 3 in here, but there is 2 of 1, 2, 3, isn't there? Because if you use a 3 in either of these, you can't use a 2 in them. And if you use a 2 here, this can't be a 3. So there is a 1, and there's a 2 or a 3, and there's something else. So what is the minimum these can be? They can't have a 1. They could have 2, 4. That's the minimum they can be, 2, 4. So that's 6. So this cannot be 6. So if there is a 2 in here, then they're minimum 7, which means this is minimum 1. This, I'm curious because this digit sees these two. Really? If this is a 2, double 1, this can't be a 1. Minimum 2. Why does this have to be 3, 4? Well, this could be minimum 2, 4. I don't understand why you can't do this. Because that would be 8. Isn't that right? Malrog, couldn't you do this? Or are you also trolling me? We know this is, so this is minimum 6, right? So this is 1, 2, or 3. If this is a 3, no. No. How do I use this fact that there's a 1 in one of these cells? Hello, Qodec. Welcome. We're solving 9 archers by KibbyAzure. Can't repeat digits. Yeah, that's fair. That's definitely an easy mistake to make. It would definitely have no 1s on the arrow for sure. And that you were probably using a quick proxy for no 1s on the arrow, 3-cell arrow must be 2, 3, 4. But I think it can be 2, 2, 4. I think, anyway. Because the 2 being here means the 2 doesn't have to appear on here. Which is annoying. Okay, we've been thinking a lot about the 2. What if the 3 is in here? What if the 3 is here? Because this could be a 1 or a 2. It's annoying. Jumping on the bandwagon? Yeah, you could. I mean, I would watch. I would probably watch you stream. Very smart dude. Very interesting to listen to, for sure. So, I would watch you stream. This is... Well, this can't be a 1 then. Now, if we could just eliminate 1 from here. If we could just eliminate 1 from here, then we would know that there's 1s in these cells, which would mean that there's a 1 over here, which means there's no 1 here. In fact, if there's a 1 here, doesn't that do, like, ridiculous amounts of damage? Because that means the only place for 1 in this is here, which means this is a 3 and a 2. Which would mean there's a 2 on here, but there's no 1 here, so there would be a 3 here. 3 plus 2 plus 4, so this would be 9. Okay, that's really weird. That is really weird. If there's a 1 over here, that means that this is 2, 3, 4, and it's 9. I might be silent and just do explanations in O's. Honestly, that sounds hilarious, and I might even do that for an entire stream. Oh. Ooh. That would be kind of funny. But I would probably lose subscribers like exponentially if I did that. But it would be funny. So we'll think about it. What about 4? What about 4? We've thought about 1. Right now I'm thinking about what the 1 in stabby arrows does to either row 1, column 8. Oh, row 1. Row 1, column 8. Or row 8, column 2. Stabby arrows. Oh, these short ones? Yeah, I don't know. I'm not sure what's intentional here. Although this one... Oh, that one seems really hard. Because that locks 1 out of both of these. And it means that the if 1 is here, right? Then how can you, then one of these two is going to be a 2 or a 3. Oh wait, no, this could just be a 1. I'm sorry. Is there something going in relationship to with the cells in row 2, column 2 arrow, and the cells in in the cell and the cells in column 7 arrows? Probably. Oh, maybe like yeah, maybe. So these digits, what is the minimum these digits sum to? And keeping in mind that there's going to be something on here. So let's think about that. If these digits, so that would be 3, 6. I think that's 2 already. I'm over counting something. So there can only be one in, oh no, there can be 2. So the minimum we can do here is 2 1s, right? And then this could be a 2. We could do 2, 4, and then like a 3, 2. I think that's minimum. So that would be 8, 10, 10 plus 5. I'm not sure what we're trying to accomplish, actually. I was trying to minimize them, but I think there's a lot of degrees of freedom. Oh God, I don't want to do set. I really don't want to do set. He said high 3. I think we're missing something easy. Something like, so what happens when there's no 1 on here? Because that's going to happen to one of these or both of them. So let's think about that. What happens when there's no 1 on here? If there's no 1, then the minimum is double 2, 3, right? Double 2, 3, which is 7. So at least one of these is 7 or more. So that means if we put the 1s here, right, then these 2 cells have to be at least 7, and so does that one. So these 3 cells are all above 7, so then these 2 cells can't be above 7. And neither can that one, neither can these. 7 and above. But what does that do? What does that do? T-Rex, is there something obvious we're missing, or is this the hardest part of the puzzle? Or is there something obvious I'm missing? I think the answer is almost certainly yes. Maybe we should think about 4, because I was going to think about 4 and 5, but I stopped myself. So, oh wait. Yes, we need to think about 4. Yes, we do. Because if this was 2, 4, which I've said many times that this could be 2, 4, then this can't be 4. But then one of these would have to be 4. This one being 4 means that this has to be double 2 because we know there's a 1 in these cells, and if there was a 1 here and a 1 here, is that possible actually? Could we do 1s here? I've never actually considered this. No, because that would require a 3 here for the 4, and there's a 3 already here. So I don't know if this can be 2, 4, because there's nowhere to put a 2. There's nowhere to put a 4 then, because you can't put a 4 there, you can't put a 4 there, and you can't put a 4 there. Isn't that right? Am I wrong with that, or is that? That's totally right. You can't do 2, 4. So this can't be a 3, because if it was, and it definitely can't be a 9. I know the program wanted to put that in. I don't know why, but it definitely cannot be a 9. And it can't be a 3 because this can't be low enough for it to be a 3. And that means it can't be a 7, right? Because this is at least 2, 5. So if row 6, column 6 equals whoa, okay, so Insanity Cat or Totally Normal Cat says that hello, Zeno, whatever. Welcome to the stream. So if these are both 1, then row 1, column 8, and row 8, column 2 have 2 on them. Yeah, because if you did without 1 and 2, you have to do double 3, 4, and that's 10. So they both have 2 on them. So there's a 2 in here, and there's a 2 in here. So these can't be 2, is what you're saying? Which would mean that we have to put a 2 on here. Why can't this be 1 then? Therefore, 2 in circles has only one place. Row 2, column 7, this one. So this is a 1 then. Oh, I see. Okay, so if either of these are 1s, then these are 1s, which rules a 1 out there. If this is a 1, then the only place to put a 2 in a circle must be there, which places a 1 here, and that's not a 1. So this is a 2. Really weird. This is really weird. I don't even know, is this even how you're supposed to solve this puzzle? So this is the 2, and this is minimum 5, oh wait, no, minimum 7. Didn't we say that? Minimum 7? So this is a 9. That's just true, isn't it? So this is 7, so it's either 2, 5, or 3, 4. Now I haven't considered 3, 4 yet. Welcome home. I don't know why, but that's so funny to me to just say welcome home to someone who's not in the same house as you. That's vaguely what you did as well? Huh, it's really interesting. It is a really tough deduction. You said this is high 3. I think this is at least 4. Yes, let's digit dance. I forgot to show off my cat the other day, so I'll show him off tonight. Very clever, absolutely. This being a 2, so if this was 3, 4, then the 4 would have to go in here, along with the 2. So this would be a 2 and this would be a 4, which would need 1s on both arrows, and that's not possible. So this is not 3, 4, it is 2, 5. That is definitely not a high 3 deduction for sure, I think. So there's a 3 in here, and it doesn't go here because that would place a 3 in here. And there's a 2 right here. This is definitely a 2. So these are 1s. That's not a 1. That's not a 3. Or a 4. And it's wait, where do we put a 5? Because we can't put a 5 here anymore. because this can't be double 1, 3. And there's no way this adds to 5 without that. So that can't be a 5. This can't be 5s. And these can't be 5s because there's a 5 in here, so this is a 5. No, it's okay. It's okay, Therex. I understand you were tired probably and thinking that it was easier than you thought it was, and it happens, you know? Don't worry, don't apologize. So this is 5, so then that's a 5, so that's a 2. No ones on the arrow from row 8, column 2. Oh yeah, you're totally right. There's a 1 pointing over here, so this has to be at least 7. It can't be 9. Let's note that none of the arrows can be 9 anymore because we use 9. And this can have a 1 on it still. You want me to go back? Okay, so let me open this over here because I know that CTC loves to just get rid of your undo history. But the reason why, the reason why this is a 9, and I know it's very confusing, so it does happen. The reason why this is a 9 is because if it was an 8, well, first of all, we know that this is not 2, 4 because then there would be nowhere to put 4 in any of the circles because you'd have to use a 2 here. This would be double 1, and you can't use a 4 here then, and you can't use a 4 here because that sees this. So then the minimum this is 2, 5, and 3, 4 doesn't work either. We've figured that out now. The minimum this is 2, 5, so this has to be a 1. Or so this has to be, and this has to be a 2 because even if none of these two are 1s and this is a 1, then this being 2, 5, no, right, if these two are 1s, then there's a 2 on here and there's a 2 on here, otherwise they're too big. So then there's no 2 in these two arrows. So then there must be a 2 here, which places a 1 here, which places a 2 here. So this cell is always a 2. Yeah. Did that make more sense, Mara? Okay. I think it's just hilarious, actually, that right, okay. You got that this couldn't be a 1. Okay. I think that's the hardest deduction so far, is that that can't be a 1. That is a chain and a half, for sure. It's... So I don't know if I'd say it's a chain. I mean, okay, this is a chain. This is a chain. Oh, it didn't matter. Interesting. Okay, well, yeah, you're crazy, totally normal cat. But yeah, this is definitely a chain. But we definitely noticed that these couldn't be 1s if this was 1. And the fact that they have 2s on them is kind of cool. So then these can't have the number that is that has to be on here. Is sort of the idea. So it's, I don't know. I would call it a chain, but there is a lot of there's a lot of logic that goes into it. So I don't really hate it, is the thing that I'm trying to say. I don't hate it. Whereas I hate long chains. This 2 gives us a 3 and a 2. So there's a 2 down here, and this 3 tells us there's a 3 up here. Now... just trying to look at more 2s, but I don't think they're very useful. Actually, where does 4 go in an arrow? Because 4 either goes here or it goes in here. Four goes in here, then this is a 1-3 pair. Yeah, I think the telegraphing is really cool. I think these short arrows, seeing all of this, I think it's very minimalistic, and it's actually really impressive for a sort of like newer setter. Very, very cool stuff. I really like where this is going. Where this setter is going. I think he has lots of potential. And lots of already skill. Lots of potential. That's sort of lots of potential is such a obnoxious thing to say. You're not there yet, but you might be eventually. I don't think the lower right arrow in box 5 can be a 1 because it breaks the upper arrow in box 2-3. Can't be 1, or you don't think it can be 1? Anyways, repeat 2 on the row 8. Oh yeah, definitely we have to, do we have to repeat the 2? Oh, if we don't repeat the 2, then it's going to be, there's going to be either double 3 2. Wait, double 3 2 works, doesn't it? Doesn't double 3 2 work? These are the same digit for sure. That's definitely true, totally normal cat, but can't you do double 3 2? Or double 2 and 3 or 4? Double 2, 3 is 7, double 2... Doing Qodec math yourself, okay. I'm glad that I'm not one of the streamers. I feel like I'm about to accidentally roast people for no reason, but I was gonna say I feel like I'm being good at not being one of the streamers who would just believe something that someone says without actually proving it to themselves. But there is no streamer that does that, so I don't know why I'm roasting no one. I should have just not said that. I'm gonna cause beef over a fake comment. Beef in Sudoku streamers. That's actually hilarious. So this can't. It can be 7 or 8. So what is the digit that is in here that's not 1 or 3? It's either gonna be 7, 8, or 6. Well, these two can't be 7. So let's just pencil mark these all. 6, 8. That can't be an 8. It's disgusting. I wish I didn't do this. 9 in box 3. Oh. 9 in box 3 is placed because these 9s, get rid of these cells, and 9 can't be on an arrow, and 9 can't be on the cell because unique arrows. So down here, 9 is in here. Over here, 9 is down here. This one is less useful for sure. Although if we could get rid of 9 there, we would get something interesting. The low-hanging fruit, indeed it is. In here, we need 8, 4, 9, and 6. That's actually kind of interesting. 9, 8, 4, and 6. Now that's interesting because the two likely candidates that I have in my head for these values are 4 and 6. Now that could be 4, 6, which do nothing to this. Okay. Nice. So what do we do next? Maybe we look at this row, which is kind of needing some values in it. This can't be 3 because one of these is 3, which sees that cell. If this is, wait a second. No. Ignore me. I don't think the arrows on the right of box 5 can be a 1-3 pair. Like these two, if this is a 3 and this is a 1, then this arrow might be broken. Huh, okay. So let's think about this arrow more. So if it's 6, could be 2, 1, 3, 2, 1. If it's a 4 here, that's not going to work. So this is the only way it can be 6, because this can't be lower than 2 or than 3. In fact, what is the values in here? If this is 6, it's too high. So it's got to be 5 or lower. A snake. Okay, interesting. So then in here, if this is 7, 3 can add to. Okay, so maybe we think about if this is 1, 3, and these can't have 1 or 3, then they're going to be minimum 2 and 4. And 2 and 4 plus 3 is 9. So this can't be a 1, 3. So this is 1, 3. That's what Tolkien's saying. Isn't there a virtual, or no, wait, 1, 2, 3, 4, 5. Yeah, that's 5 cells which have to be 1, 2, 3, 4, or 6. So these cells are an 8, 9 pair. That's really weird. So then these two cells are a hidden 5, 7 pair, and that's a 7. Oh, not 5 due to the column. Thank you. Also, I didn't pencil my rows, so. Oh, wait. Wait a second. Oh, double 2, 4. I just did the same thing that Totally Normal Cat did, and thought there had to be a 3 on here. The value in here that's not 1 or 3, I think it has to be 4 or 6, because if this is a 1, 3 pair, then this is obviously going to be 2, 4. That'll be 6. That'll be a 4, right? That's just resolving this quintuple. But then if this is a 4, then where do you put 4 in this box? It has to go there. Something going on in this row with 4s and 6s, I think. There's at least 1, 4, 6 in here. I'm not sure how to exactly describe it, but I think that this can't be an 8. If this is an 8, why can't it be an 8? I feel like it can't be an 8, because if this is, I know it can't be an 8. It's either a 4 or a 3, but why can't it be an 8? If it's an 8, oh, I see it. So in here, there's 1 of 3 or 4. So where does that digit go in this row? It has to go right here. That's what it is. 1, 7, 1 in box 4. Yeah, okay. This 1, 7 pair. Oh my God. Yeah, okay. There's a 1, 7 pair. So then that can't be 8 because there's an 8 in here. Yeah, okay. Stupid. This is 8, 6, or 4, right? Yeah. So this is 3, 4, and this is a 3, 4 pair, which means that can't be 4. Someone is... Oh, okay. the step was that row 5, column 4 has to appear in a circle, and it was limited to 2, 3, 4, 5. It sees every circle right, okay. Yeah, okay, maybe. Huh. I mean, one of you is called Insanity Cat, and Smeagol stands up tall. So I think Tall Cat is Smeagol. I'm sorry, Totally Normal Cat, but it's gotta be that way. uh so this is 3, 4, which means down here we need, oh, this is an 8 then, because there's nowhere else for 8 to go in the column. 8 is down here. So this is going to be 1, 6, and 9. 1, 6, and 9. That's definitely a 9. On that account, you're the insane one. On the other one, you're the normal one. I think Totally Normal Cat might be both Smeagol and Golem. Based on this conversation. There's definitely a 3 in here, which is, oh wait, no there's not. Yes there is. No there isn't. I'm losing my mind. Yeah, there could be a 3 here. That's, what am I doing? So all of a sudden I went very silent. I was thinking about if this was a 4, it can't have a 3 on it. Could be 2, 1, but what else could it be? Can't be anything else. So if this is a 4, this is 2, 1. If this is a 3, it could be 2, 1 for 6. But if it's not 2, 1 for 6, it could be, no, it can't be 4. It can't have a 4. So it can't be anything else? 3 plus 2 digits. Oh, it can't have a 3 in it. That's what I was missing. So it, oh, could it have double 4, 1? No, because this can't be 9. But it can have a 3 in both these positions. So then this could be a 2 or a 1, right? That's 7 or 8, yeah. Question, where is 8 in column 7? Already got it. Is this Thomas Miles? Is that Zetamath, or is that a different person? Are you on your personal account again? If row 6, column 6 is a 1, then I think you have 2 8 arrows. Do you? This is 2, 3. Isn't there always a 1 in here? Wait, didn't we just prove that there's always a... No, we didn't. Because this could be 2, double 3. Oh, and in fact, if it is 2, 3, then it's 2, double 3, and this is an 8. But then this is double 4, so this is double 3, which means this is also 8, right? That's Tall Cat's point, so this has to be 6. So that's a 1. This is a 3. This is a 6. This is a 4. These are not 4s. So that can't be a 3. Oh my god. And double 3, 2 works. But this can't be a 3, so that is a 1. So that's a 2, and that's a 4. Which means this is a 7. Which means this is an 8. Nice. Double double 2, 3 is 7, so this is double 3, 2. So there's a 3 up here. Different person, okay. I'm sorry. Nice to see you around. I don't know if I've seen you, Thomas Miles, or if I had assumed you were Zeta Math as well. I don't want to dox Zeta Math. This is not 6, 7, or 8, so it is a 4, which I did not expect. That's a 1 and that's a 3. So there's a 3 up here. We can get rid of that stupid blue coloring. I don't know why I'm being so mean to the blue coloring, but this is 1 and 9. That's not a 9 anymore, which places all the 9s, question mark? Yes, all the 9s are placed. The 1s, there's one more 1 right here. The 8s are far from placed, but there's an 8 in one of these two cells. That's definitely not an 8. 9's done. Row 8, column 4, that's done, yeah. So then in here we need 2, 7, and 6. I should stop trying to resolve it in my head and just put it in. So this is what I should do when I'm streaming, is not try to resolve things in my head for no reason, because it's not enjoyable for the audience, but for some reason my brain just refuses not to do it. So this sees both 7 and, yeah, you saw it. 8 in box 3 is placed right there. Thank you, Malrog. 8 in box 1 is in 2 positions. I bet you 8 in this box is interesting, but it's not. Row 9, yeah, we got that. These two cells are 4, 8, and what? Well, this one is not 4, 8, so that's what? That's a 5? This is a 4, 8? I think it's pretty enjoyable for audience watching you try and get out of your brain. It's the endless struggle of me trying to get out of my brain. So this is 5 and 4. So this digit should be placed, it's a 7. So then 7s are down here. Again, I'm doing the thing where I'm trying to resolve everything in my brain. This 7 does those, and then that's a 7. See, the thing is, when I make some pencil mark like this, I'm immediately thinking, if Simon made this pencil mark, I would want him to search for the 7s. So then I search for the 7s in my brain, but I'm not saying anything because I'm like scanning. So there's 7s in here. And when I was searching for the 7s, I had noticed that this 7 saw those cells, and then I saw this 7. And I was hoping that this 7 would be placed, but it wasn't. But I didn't say any of that out loud. I just sort of like went into drone mode. Drone mode. I've never said that before, but that's kind of funny. There's a 5 here, which fixes this. This is a 4 and a 5. Have we placed all the 5s? No, we haven't. And we definitely can't even do that because there's nothing in here that does the 5s. There's a 5 and a 6 in here, which doesn't do the 5s. In here, we need 5. We don't need 6. Actually, 6 is placed in this box right there. Box 8 is done. 8 and what is that? 2. So this 2 resolves that. That's a 2 and that's an 8. Have we placed all the 2s now? We can. That's a 2, which places the 7, and that places the 7, which places an 8, which does not place the 8s. Sad. That's not a 7. These 2 cells are probably resolved. In fact, they are completely resolved because of their row. That's a 4, and this is a 6, so that's not a 6, and that's not 4. Oh, and that's not an 8 either because there's an 8 above it. So that's a 4, that's a 6, that's an 8. This digit is a 3, because I must have pencil marked that earlier and didn't even realize that it was done. Yeah, let's just say you and Zeta Math have something in common uh, that I have now revealed to everyone by accident. Sorry. I should stop. It's not even funny. It's literally not even funny for anyone, but I'm just laughing because I just can't control myself. Yay, we're done. Not yay, we're done. That was a really cool puzzle, and I want to understand better what the chain had to do with that. Kurban, I'll put those two puzzles you sent me in my queue. I might, oh, I don't want to open them here. I might not get to them tonight, though. I'm going to do one more puzzle, and why am I on color mask all of a sudden? Oh. That break-in was nuts. That was really weird. Okay, and we've already done both of those, so thankfully I have two puzzles ready, although I regret them. Okay. Which puzzle next? Well, I would love to just do whatever. Oh, you're dyslexic. Interesting. I would love to just do whatever puzzles come up like from the viewers, but I do want to have a sort of process. Dismay is probably going to be awesome, but I regret you know, choosing 5-star for the end. Especially when Qodec is in chat, no. Because everyone's going to choose the puzzle, and Qodec is an amazing setter, so. Is it really 5 stars, though? I generally go for more weird puzzles, so don't let me dissuade you from picking whatever you want to see, by the way. I can do any of the puzzles, and especially because I have chat, and there are a lot of smart people in chat right now. So lots of smart people can help me if I am being slow. So don't feel like you need to pick the 2-star because it's the end of the stream. It's a low 5. I'm surprised that it's even a 5. Okay, interesting. Okay, 9 votes, 10 people, so that's the end of the poll. Smart people in chat plus you. You're smart, Malrog. Okay, we're back here, and we need to bring that up. And then I need to bring up Dismay. And hopefully, yes, okay. Dismay and CTC is what I want. No, don't be sorry. Please don't be sorry. Don't be sorry for picking a puzzle. I gave you the option of picking a puzzle, like. Never apologize in this chat. Just kidding. 1 second though. I'm not gonna do a be right back because I think I can handle it and I want to finish this up. If it's gonna take 80 minutes, I want to do it starting now. But I do want to charge my phone. For some reason, it's low, so I'm gonna plug it in really quickly. We won't even go. You guys can figure out the first step for me while I plug in my phone here. I don't know how. Don't be dismayed. No, I'm just joking. You don't have to not apologize. Sorry, don't apologize for apologizing. You. See, I'm. Yeah, that's really rude, Naverio. To vote for a puzzle and then just leave. But I'm Canadian, so if anything I do, I have to apologize for, and anything that you apologize for, I need to tell you to not apologize. It's just who we are as a society. Okay, so this puzzle is equal sum lines, which means that within each box that this line passes through, so let's say that is one pass through, that's another pass through, this is another pass through. So then this would mean that the purple digits sum to the same total as the green digit, as the same total as the blue digit, as the same total as the red digit. You're always lurking, okay. Good. You have to stay if you vote for a puzzle. I'm just joking. Okay, so let's restart the clock and we'll start doing things. Well, we can see immediately that this cell is the sum of these 3 digits. So it has to be 6, 7, 8, or 9, and it can't be 6 because it needs a 3 if it's 6, because it would have to be 1, 2, 3, and it can't have a 3. In fact, I find it very interesting that that 9, if it has a 3 off its line, must be exactly 1, 2, 6. I think that's very interesting. Totally normal cat. That happens literally every day, in every place. In all of Canada, that's just what's happening, basically all the time. Everyone is saying, oh, please don't apologize. I'm sorry for inconveniencing you to be sorry for me. And also 8 is also 4, and so if this is 9, it's 1, 2, 6. If it's 8, it's 1, 2, 5. If it's 7, it's 1, 2, 4. Okay, I find the 1, 2, 6 thing with 9 very interesting, but this, I had never even considered this. That is really weird. Even if the rule set has been used 1,000 times, we'll find a way to gain unique deductions out of it. It's actually really weird that this deduction is coming up because I was thinking about setting a killer Sudoku with something similar. So that's funny. Okay. So now this digit is also high. Let's just identify some very easy wins. This digit is also high because it's pretty symmetric around this diagonal, so except for this weirdness and whatever the heck this is. Actually, whatever the heck this is kind of interesting. There's 4 cells here that sum to the same as 2 cells. It's not that interesting, but it is a little bit interesting. A 3-cell sum to a single digit must have at least 2 numbers from the set of 1, 2, 3. That's true. Yeah. 3 cells, no repeats in a sum 6 to 2 has 2 of 1, 2, 3. Yeah. Definitely. This digit's the same as this digit. So in this box, that digit goes in here. Oh, actually, wait. This digit and this digit together sum to at least 15. So this digit is at least 6, 7, 8, 9. Because if you put the minimum in here, 1, 2, 3, 4, 5, then this would sum to 15. So these two digits would sum to 15, right? So then this would have to be, sorry. So those two digits would have to add to 15, and at minimum, it's going to be a 6, 9. So the lowest you can put is 6. Wait, what? I don't understand what you're saying. I think numero means that if there is a 3-cell arrow, then it always has 4, 5, or 6, because if it doesn't have 6 in the bulb, then it will have 4 or 5 on the line, that sort of thing. Yeah, what Nordy says. So then could this digit go on here? If this digit went on here, then that would mean that it's lower than this. Well, the only case for this digit can go on here is it's a 6 and this is a 1, 2. Okay, so there's maybe an easier way to see this, but if this is a 6 and it goes on here, right? Then this will be a 1, 2, and this will have to add to 6, but it can't because there's no 1, 2 anymore, so it has to be 3, 4 at minimum. I know there's an easier way to think about that, and I think it has to do with making 4 digits add up to 1 digit or something like that. Yes, okay, so if this digit went on here, then the rest of these 4 digits would have to add up to this one, because these two add up to 15, so if you put this one on cell, then these digits add up to the remainder of the 15, or at least 15, whatever it is. So then this digit would have to add up to 4 cells, which it can't because 4 cells that are unique add up to 10. So this does not go on here. So whatever this is, let's color it yellow, has to go into one of these 2 cells. So therefore has to go up here. And this digit, let's color it red, has to go down here, so also has to go up here. Now this digit is a similar case. Yeah, okay, so is a similar case where it goes here and in here, but that's a little bit less interesting because this is interesting because it overlaps that. Although this digit can't go on here for the exact same reason as this digit can't go on here. Because if this digit went here, then these 4 cells would add up to this cell, as we said before. So then this digit goes in one of these 2 cells. Interesting. So if these 2 cells were red and yellow, then oh wait, no, that's wrong. That's wrong. I was gonna say then you couldn't put red and yellow up here because they would. I don't know why I thought they couldn't. Neither of them could go on here. They can definitely go. One of them can go on here. One of them would have to go here. Otherwise, this would be 0. Although, oh wait, we can make the same argument over here. What are we doing? Why are we not using the fact that the grid is symmetric? So this is, so everything we set up here is exactly true down here, which it befuddles me how on earth I missed this for like even a second. Especially when I said, oh, this is a symmetric grid, so we can use everything up here, down here, and then didn't. So there's blue and green over here. Because of row 1, column 1? I'm not sure what you mean. So what is the maximum of these cells now? Because it can only include one of 6, 7, 8, or 9. So the maximum of these cells is going to be 12, which is 3 plus 4 plus 5, plus 9. So that's 21, which is more than 2 cells. So that is completely useless. At least 1/4 of your puzzles seem to use similar strategies. I don't know if they're all different. Only one of them could be the same, actually. And that digit would go right here. So one at most, well, obviously green and yellow are different, but blue could be yellow if it was here, but if blue is yellow, then red is different from green. So in the set of yellow, green, blue, and red, there is one digit which could repeat. But only one. In fact, let me think about this for a second because, oh no, wait. No, this one could contain a high digit. I don't know why, for some reason, I thought there couldn't be a high digit on here at all. Of course there can be. So maybe we need to think about the sum of this. Maybe not. This is a very strange puzzle. How does this work? How does this uniquely solve? Is it this now? Okay, so let's think about maybe this cell. If this cell cannot go in either of these because one, it sees these rows and columns, and two, it's 7, 8, or 9, so it can't go on a 3-cell line. Well, a 4-cell line or whatever, you know what I mean. A 3-cell arrow, basically. Row 6, column 6 must be red or blue. Oh, yeah, for sure, because there's only one repeated digit allowed, of course. So then if it's red, so it definitely goes into here in one of these for like 2x2s. When I was listing the possible repeats, I said this one and this one and this one and this one, but also red and blue could be the exact same digit and go here. That would be fine as well. I just didn't say it. I knew it was true, but I didn't say it. So just in case someone was wondering, that definitely could happen. What if, so either one of these would put that digit in one of these sort of quads. Wait a second. Wait a second. This is so familiar. This arrangement here is so familiar. Last solving stream, we were talking about my puzzle called Harmony. And this configuration reminds me so much of that. That puzzle was based on figuring out that these digits, which were like a 6, 7, 8, 9 triple, basically here, I think it was maybe like this actually. But anyways, that they what was it? Something about if they contain 2 repeated digits, then they something about box 9 is very suspicious. Suspicious. Is that really? That's cute. So something is off. Something is weird. Does this have to have a high digit on it? And probably if it's 4 or 5, that's not enough. So it has to have a high digit on it. And that high digit either is either a 6 in this combo, or if it's a high digit and it's not 6 and it's in here, there's so many conditions, then it goes right there. If it's a high digit and it goes in here, then it would be in there. That's not that interesting. Okay, so maybe we need to think about these are not high digits at all. Oh no, they could be, because this could have a repeated digit, right? So what is it that we're supposed to appreciate here? It feels like that butterfly puzzle from Hoila and Mr. Menace. I feel like I am getting butterflied on. Vague hint. One box is very interesting about how its region sumlines is distributed, arithmetic-wise. I mean, there are 2 boxes which are very interesting in terms of that, but one of them is this box. Oh. So there are 3 lines that are entering this box. And they encapsulate the entire box. So that means they have to sum to 45, of course. So they are at, no. They aren't at minimum 15, but they could all be 15, or they could sort of oscillate around there. It's interesting that every cell in 4 boxes are on lines. That is interesting. I'm wondering, can we narrow down the sum of these 2 cells based on like maximums and minimums of these cells? So a maximum of 2 cells in a box is going to be 17. And I think these could both be 17. Because we could definitely put an 8 and a 9 in these 3 cells, or even one here. So if these were 17, then these would add to 17. 2... No, okay. So then if this was 17 and these were maxed out as well, then this would be, 17 plus 24 is going to be 31. No, wait, 17. No, sorry, 41. So then this would be a minimum of 4. And I don't think it's 4. So if this... So there's no way that this is 17 and maximum. This is going to be like some average value then. What is the maximum here? Because it can't have, it can only have one of 8 and 9. Or sorry, one of 6, 7, 8, and 9. So it can have one of 6, 7, 8, and 9. Didn't we work out the maximum before? It was 12, it was 21. 21 was the maximum. But 21 in 2 cells doesn't work. So what's the maximum in terms of this? What's the minimum of 3 cells? That's the question. What's the minimum of 3 cells is 6, right? So if we did 6 here, and minimize these, then we would have 6 plus 21 is 27. So then these cells would add up to way too much. Would they? Yeah, they would have added way too much. Oh, 18. I think I was carrying the 1 again in the wrong place. I don't know. I think I'm kind of tired. So the maximum of these cells is 17, of course, because they're 2 cells. But if we minimize this, then they're 18 at maximum. So we can't minimize this? No, we can minimize this if we maximize these or made them bigger. So what this has told us is that this is not helpful at all, essentially. That this is not helpful at all. Oh wait, these can't add up to 6. If these added up to 6... okay, so these two... (17 times 2 maybe is 34. 45 minus 34 is 11. So the minimum of these cells is 11. I'm going in circles here because like I just keep, I'm choosing exactly the wrong place to look every time, which is a little bit frustrating, but it's okay. So these are minimum 11. Minimum 11 plus 21 is 32. 32 difference of 45 is 13. So the absolute maximum of these 4 cells, no, yeah, the absolute maximum of these 4 cells is 13. And 13 needs a 1. So that's a pencil mark. First pencil mark in like 20 minutes. But we know that there's a 1 on here. Oh boy. So there's a 1 on here. No, I am picking the wrong places to look. I mean, so Naverio, is it the right place to look to try to do this one and then realize that it's increased by this, and then realize that this one is increased by these minimums? Or was it better to do this minimum and then go here and do the complete opposite way around? Okay, so if these are maximum 13, then they can just barely have 2 high digits in these cells, and that's only 6 and 7. I'm approaching it differently. I honestly don't know how else to approach it. If this digit, oh, this is probably how you're supposed to approach it. Oh my word. See, if I had done this puzzle first, I think I would have spotted this instantly. But I didn't, because I did some coloring on here, and I didn't spot it because I didn't think about if this cell was on here. That's what we need to think about. Let's just say this cell was the same as this cell. Is that a problem? Here, Nordy, you tell me, is that a problem? Is there something wrong? Well, what of that cell? Now this cell is the remainder of this sum. Oh, it's 3 digits, which does work. Wait, that totally works, doesn't it? Does that work? Can that digit be on there? For some reason, my brain told me it can't be on there. Nordy, please tell me. Can that digit be on there? I thought for sure it couldn't be, just when I said that. I'll also note it's 26 degrees in my apartment now. It's quite warm outside. So if I seem like I'm losing my mind, it's because I am. Only if it's high. Only if it's 6, 7, 8, or 9. So we can only put 1 high digit on there. But whatever high digit we put on there can't go in here. Box 1's line is the correct place. Oh, Celsius. Yes, sorry, Celsius. I forget there's some stupid Fahrenheit. Is the correct place to look. You know the secret. What does this tell you about the other side of the lines and the high digits? Well, these cells add to 45, which is probably the right place to look. Yeah. So how can these cells add to 45? Well, this can only have 1 high digit on it. So if we did 14 there, which is the maximum, then these 4 cells would have to add to 45 minus 14, which is a whole lot. 31, which is greater than 30, which is the maximum of 4 cells if they are unique. So they are probably all high. I'm 31 double, yeah, they are all high. All of these cells are high. And there must be a high digit in here, because if this is 4 and 5, then I think it's broken, because then, no, wait, these could add up to more than, yeah, I think those could add up to more. So if those added up to, didn't we figure those? We know that this is minimum 11. We do know that, right? Oh, there definitely is a repeat in these four. No, it's a good reminder, Ambrose, that I don't I live in Canada and it's Celsius. Yes. 26 degrees Celsius. What is that in Fahrenheit? 26, something like 100 something or something. Like it's just ridiculous. 78.8 degrees. Divide by 11 times by 65 or something. Add 38. We already knew there was a repeat? It's not min 14. There's no way it's min 14. Max 14. Max 14 is just because 9 and 5. That's it. Because those are the highest digits we can put in there. So max 14, min 11. And we can only use one high digit. So we have to use one high digit, don't we? Yeah. So we have to use one high digit in here, so there's definitely no high digits in here. So these are low digits, or 5. Yeah, whatever. Imperial system units are just ridiculous, so. I'm both a Canadian and a physicist, so I think imperial digits are just ridiculous. If there was a high digit here, which there could be because we know there's a repeat in here, then this high digit could not appear in here. Which is quite interesting because that would mean that, so if we do double 9 and double 8, well, if this is high, then that's already broken. If we did double 9 and double 8, then this would have to be 8 and 9. So we would get away with double 9, 8, and 7, which would be 33. Which means that these two would have to add to 12. But then this would have to be a 6 if we did 7, 8, and whatever. And if this is a 6, this can't be another 6, so we actually can't put the high digit here, we have to put it here. It has to be 1, 2, 3, 4, 5. Kelvin master race, true. But at least there's a reason for Celsius, and there's a reason for Kelvin, but there is very little reason for Fahrenheit. It's just, oh, this number's nice. I like that number. Or it's some like, it's like the heating point of air or something that's useless. That is a neat deduction. I like that one. So these two, yeah, okay, so we already know that. So this digit, if that digit doesn't appear in here, isn't that the same thing? Because if this digit doesn't appear in here, don't we have the exact same problem where this has to be 6 and this has to add 12? I think that's true, right? If that digit doesn't appear in there, then we have the exact same thing. Yeah. So that digit does appear in one of these things. How do we use that? If it appeared in here, then it would be down here. Oh, it could be up here, actually. Okay, so what are the values that this could even take on? Because if this is, we kind of know what values it is, right? Because either you're missing the 1, the 2, the 3, the 4, the 5 sort of thing. So what values could it take on? It could take on, well, we're doing 15 minus one of these values. So it's pretty easy. We could do 13, 14, wait, sorry, 13, 12, 11, and 10. There's 4 of them, right? 13. Yeah. So the minimum value of these two cells is 10. I don't know why that took me so long. 1, 2, 3, 4, of course. 10. So there's always a high digit in here. At least one high digit. And there can only be 2 high digits in the case where it's 13. So that means that there is one case where this is 15, and that's if this is 6, 7, 8, 9. But if that was the case, then these would be maximized, right? To add to 13. So this would be a 2. If this is a 2, then this is 11. And these have to add to, what is that? 45 minus 11 is 34. 34 minus 17 is, so these would both have to be 8, 9. And if these are both 8, 9, does that mean this is 6, 7? Yeah, it does actually mean that's 6, 7. My brain is like confused whether this is interesting or this is the opposite of what we're supposed to do. Oh, maybe it's this. Or this. Wait, there's 3 high digits in these columns and rows. It's not actually that interesting. Thought that was more interesting than it is. This thing in box 9 I wish did more things, but I don't think it does. You know, this also looks the same as that thing that in Harmony. I really like Harmony. That's a good puzzle. So these are both high. So if these are both high, you know what's interesting? These can't add to 15. Well, they can. Can they add to 15? Yes, they can. But they can't both add to 15 is what I was thinking. Because this is maximum 14. Right, because there has to be a repeat in these. I'm just going in circles now. This is big dismay. Why did I say this has to be blue or red? That's not even true. That's not even true. This could be purple, and this could be red, and that could be blue. So this doesn't have to be blue or red. I think someone suggested that. Don't think that's actually true, unless there's a reason for that. I don't think that's true. Is that unless someone wants to tell me otherwise, I don't think that's true. Probably one of Nordy's bamboozles. Hello, Grockles. We're currently dismaying. Consequences of green, yellow being 9. As in, if these were 9, then there'd be a 9. Well, there has to be a 9 in here, right? If you did double 8, that would just be worse than 9. So you can't do that. Dismay, yeah. Which may? Dismay. So you can't do, you need a 9 in here. So if there is a 9 in here, then there will have to be a 9 in here. Which means there is a 9 there then. Which does something, I guess. I'm not sure what it does. I mean, if, okay, so if 9 can't be here, right? That's impossible. 9 can't be on here. So 9 in both of these, in these boxes, is in here. But if 9 is not in here, then 9 being in here seems unlikely. Because this could be maximum of, or minimum, so, wait, no. No, this could still be just 11. And then you could still do 13 with a 9, 4. So why is 9 in yellow or green bad? Maybe this is more important than I've been giving it attention to. Like, I don't know, this seemed cool at first and then it just didn't do anything. I mean, this did stuff, right? But this, I didn't do very much, at least not that I can see. Nine in there, 9 down here, a 9 in here, so there wouldn't be a 9 there. So there'd be a 9 up here. could be a 9 in blue, but there couldn't be a 9 in green, so there would be a 9 in here. Can't be a 9 on that line. Those are not 9 because of this 9. So if there's only one 9 on the line, then we could increase the count only by 2. No, we can't increase it even by... No, we could... Yeah, we can only increase it by 2 by doing double 7... No, wait. 8, double 8, and then 7. Right, double 8 and 7. Double 8 and 7 would increase the count to... Simpler question is if row 2, column 5, and row 3, column 5 can add up to 10. Specifically this one, or like is there some asymmetry, or is it just these two cells sort of thing? The secret pattern? So okay, wait, maybe it's this box adds to 45. So these 2 digit, I don't know. It doesn't make any sense. No, I don't like that. So if this is 10, 10 plus, I don't know, 17. 10, no, we're not trying to minimize that. We're trying to, I don't know, maximize? No. If that sums to 10, then you have 7 cells which sum to at most 36. No, not 36, sorry. At most 28. 28, and then you've used 10, so the other cells, sorry, minimum of 28. So the other cells add up to a minimum of 18. Oh, okay, so if you make this 10, then these cells add up to a minimum of 18. Which you can't do because you can't do double 9. So these cannot add up to 10. So that means that you can't miss out the 5 here. So then this can't be a 5, which means the minimum or the maximum these can be is now down 1, which means the minimum that these can be is now up 1. It's now up 1. So it's 32 minimum. Uh, 45 minus 28. I didn't do that. I did 28 minus 10. Why did I do that? Does that even make any sense? 45 minus... Did I say 45 minus 28? I didn't think I said that. I said the minimum of these cells is 28. So if you take 18 out of, or if you take 10 out of that, then these cells add up to, okay. I don't know. Maybe I said that. Probably. I'm pretty, yeah, out of it. Anyways, so this takes the count up. Now this actually can't be a 6 now, right? Because the minimum here was 11. And if this was a 6, this can't be high enough. So there's a 6 in one of these two, which means that nothing. Doesn't mean anything. But the fact that the count is up now, if I include a 6 in the sum, if I do 6 plus 9 plus 9 plus 8, that's 32 exactly. Ah, so close. Okay, but now if these are minimum, or sorry, if these are maximized, then these are minimized. These are minimized. The minimum value is 10, which we know doesn't work, but now the minimum value is 11. So 11. The minimum value is 11. And 11, wait, wouldn't 11 mean that this is an 8-9 pair? Because 11 here would mean that this is 17 in both cases, right? Because we were at 18 with 10, and that doesn't work, but 17 for both of them because they're both the same. If they're both 11, then this is an 8-9 pair. And wait, there's a 6 in here. Oh, that's it. That's it. There's a 6 in here. So one of these sums has a 6. One of these lines sums to 6 plus something. It doesn't matter what, but that's going to be maximum 15. So that means that this sums to a maximum of 15 plus, wait, a maximum. I'm trying to do a maximum. No, a minimum. A minimum of 15 plus 8 plus 9, all that, 32 minus, or 45 minus 32 is 13. The minimum is 13. That's it. That's it. That is it. So I don't know if I even explained it correctly, but so let's just say this is a 6, right? If this is a 6, then we know these two add to 15 at least. So then this has to be 1, 2, 3, 4, 5. But if this is 1, 2, 3, 4, 5, and then then we know that this has to be an 8, 9, this has to be a 6, 7, that's just what it is. That is literally just what it is. Exactly. So then, and we don't know where the 6 goes. We just know one of these two is a 6. So then one of these two boxes has that situation. So then one of these two boxes will have the sum here be 13, but it's the same sum. So it is 13. That is so cool. That is so cool. I love that. Okay, so now we have to figure out what 13 is. 13 is the absolute maximum that these can be. So that's going to be no 2. And if there's no 2 in here, then this is a 2, and this is minimum 11, remember? So this is 9. That's cool. So that's not 9. We can get rid of these corner pencil marks. One of these is a 6, 7. This sums to 11, though. We know one of these sums to 17. So we know 17 plus 11 is 28. 45 minus 28 is 17. So both sums are 17. So these are both 8, 9. That's so weird. Wow. Yeah, I think we can do it. Let's do it. Okay, so this is 17. These are both 6, 7. These are both 1, 2, 3, 4, 5. One of these is a 6. Neither of these are 9. And they both add to 15. So they can't both be 6. So one of these is a 7, 8. So there's no repeat. There is no repeat. In these 4 cells, there is no repeat. So that means that... What did we say if there's no repeat? There's something going on if there's no repeat. That means something. With the hints you provided, yes. Yes. Indeed, that's how we win. Is by using your hints against you. Oh, this 8, 9 and this 8, 9 are, of course, putting 8 and 9 into here. So this is an 8. So this is a 6, 7 pair. And this actually does remind me of harmony, like almost exactly. So then this is an 8, 9, except way nicer. Way cooler. These are not 2s. I have no idea. There is a 6 or 7 on here. So there's a 1, 2, 6, 7. This, because there's no other place to put 6, 7 in the column. Wait, these cells see this cell, so that's not 6, 7, that is 6, 7, and that is going to be green. Wait, so green... Lowercase x, yeah, that's a good idea. This can't be 6 or 7. Oh, actually, wait, that can't be green. What am I doing? That can't be green, that can't be blue. That can't be red, and that can't be yellow. We know these are individual... These are... So this is green, this is blue, this is yellow, and this is red. So that's not red, that's not yellow, that's not blue, and that's not green. These sum to 11. So if that was high digit, row 7, column 7, this cell sees all of all the high digits. So it is a low digit, and it can't be 3 or 1, 2, so it's 5 or 4. So this set of digits can't be 4 or 5, but it doesn't sum to 9, so it doesn't matter. There's definitely an 8 over here. An 8 in one of these 3. I almost didn't put an 8 here. I know putting something after is a solution, but very unsatisfying. Yeah, true. So this 1, 2 is going to go here and going to go down there. It's also going to go in here. Nine in box 9 is in one of these 2 cells, so that's not a 9, that's a 9. That means 9 is up here. So that can't be blue. If this was blue, then that would be, wait. This can't be blue and 9, is what I was trying to say. But it can't be 9 anyway, because these digits would have to add to 2. In fact, this can't be 9. So maybe green down here is interesting. Yellow in this box is placed right there. So then yellow in here is in one of these 3 cells. It could be 6 still, unfortunately. Red can't go in any of those cells, so it's in one of these cells. Blue is similar. On XD, I like XD. I don't know about both lowercase XD. It looks kind of weird. Looks kind of weird. Thank you for the compliment on the good lifting. I have to record information or I will forget it. Either this is an 8 or it's low. Definitely yellow over here. There's 9 in here? No. Oh, wait. Where does 8 and 9? Oh, wait. 8 and 9 go in these places. Okay, so I can't take it anymore. Please resolve the 8 as 1, 2, 5. I will not. I will not. 1, 2. Let me just leave it as 1, 2, 4 for you. So this can't be 6 or 7. Can still be 3, 5. Oh, neither of these can be 6 or 7, so it is 3, 5. So these are all high. Oh, these can no longer be yellow. I can take it. So that is yellow. So that's green. So this is blue, and that's red. Okay, I'll change it. Okay, now yellow can't go anywhere there, so yellow is in one of these 2 cells. Yellow not here, yellow not there. Yellow, yellow everywhere. Red in this box. Unsurprising. Red in this box is surprising. I don't actually care about the time, by the way. Oh, both red and yellow, or both red and blue see that cell, so that's... Oh, this is definitely blue then. Ah, so that's not blue. I feel like I'm going to beat your time with major hints. You did your part to slow me down. Oh my god. How have we not resolved everything? I say as I didn't even resolve this. That's not a 5. This is a 1, 2, isn't it? And that's not a 2. So that's a 1. That's a 2. Those are not 2. Oh, that was less exciting than I actually made it out to be. There's green in here. Useless. Why do I keep doing that? It's gonna hurt my neck. Do I actually have to, like, figure things out? Yeah. Two in box 6 is placed. So that's not a 2. This is a 3-5 pair because of this ruling out 3 and 5 from here. So this is a 4, 6, 7. The row 9 line in box 8 must use an 8. Oh, yeah. This has to have a high digit to sum to at least 10. So that's an 8. That's a good point, Ambrose. Now, red can't go down here or in here or there, so red is in one of these two cells. Now, if red was here, then that would either be 8 or 9, which would mean these cells have to add up to at least this cell, but this cell can't be greater than 5, so that does not work. Red is not here. So that is red. And that's 8 or 9. That's not red, so this is red. Max of 13, yeah, absolutely. It can't be 10. Can't be 10. So, hello, Andrew Montanolan. I can't pronounce last names. I'm sorry. I don't think you should figure things out. That would be a major spoiler. Yeah, I should just... Yeah, I'll just stop here. You guys figure it out. Bye. Okay, so, if this is 6 or 7, that could still work, I think. Yeah, that could still work. Oh my word, I can't even with you, Gruckles. Oh, this sees a 3 as well. So this is either 12 or it's 13. Well, it definitely needs a 1 then. Oh wait, there's a 1 in here and a 1 in here, so those are not 1s. So either this is a 1-2 pair or this is a 2, because there's definitely a 2 down here. No other 2 in the row. So these are 1, 4, 5, and 2. If this is a 1, 2, as well have to add to 12. Well, no, it doesn't. Sorry, if this isn't a 1, 2, it'll have to add to 13. So if it adds to 13, then it will be in 1, 4. Wait, that means if this isn't a 1, 2, then it can't add to 12 because 4 digits without 1 and 2 can't add to 12. So it's either a 1, 2 or this is a 5. So this isn't a 5. So if this is a 1, 4 and adds to 13, then these two cells add to 8. Which would make them exactly 3, 5. Whereas if this is 1 and 2, then these either add to 10 or 9 without using 1 or 2. So they would have to add to 10. They'd have to add to 10 without using 5. Can you add to 10 without using 5? If this is 3, 5, yeah, okay. Yeah, A single pencil mark from it? Why are you doing that? Yellow in box 7? I think this still can be yellow. I'm not doing that. I'm not doing that, Insanity Cat. You're insane. If this is 6 or 7, this can still be 3 exactly, I think. Yeah. Oh, wait. No, that's not true. Wait, is it true? No, this could be 6-4. This could be 6-4. It's either 6-4, 6-3, 7-3, or 3-5. There's no way I was supposed to go through all those options, but I did anyway. Why does it even matter if this is not 1? Let's follow this chain. Row 1 is not a 1 as it would put 1 in one of no. In one of row 6, column 2 or 3, and one of these two. But one of those is a 7 sum, which would need 6 plus 1. Okay, so that's not a 1. Thank you, totally normal cat. So... well, you can say the same thing about 3, because if there was a 3, one of these is a 6, which if it had a 3, then it would be double 3, which doesn't work. Now we're just goofing around. We're not even going to beat Navarro's time. This digit is 3, 4, 5, or 1. Yeah, okay. True. These digits are all low. Okay, so let's think about one of these is a 6 or 7, right? So if these add to 15, then this would have to be a 2. If these add to 14, then it would need to be a 3. 16 would have to be a 1. So whatever goes with the 6, 7 will have to be 1, 2, or 3. That's not even helpful. Divide your time by the number of people in chat. I'm pretty sure that beats Navarro's time. Yeah, that's true. Navarro included. I believe there are some digits in this puzzle. I think you might be right about that one, Garkles. So up here we have 4, 1, 5. So that sees every other digit. There's, I guess, 1 and 5 over here. So there's either a 2 here or there's a 2 on this line. I'm not seeing it. Definitely a 2 down here. So there's definitely a 2 in one of these 2 cells. Multiply? No, 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 no. Divide. Divide. These digits are all low. Yeah, we should gear them up. I don't know if that's true. There are a lot of things to filter. Okay, I need to finish this quickly. Because it is dinner time. Why do I not have any ideas? So it's probably this line, right? This line is supposed to disambiguate everything. Or maybe it's here. So this is a 6 or a 7. If it's a 7, then these two digits add to 4. If it's a 6, they add to 5. So they can't have a 5 in them. So what happens to the 5? 3 and 2, either 4 or green. Row 1. I don't know what I don't know what that means. Row 1, 2, 3, column 8. Well, there's definitely 2 and 3 in here. I just didn't pencil mark that. Stop, Ambrose. Okay, so what happens to the 5 in here? If the 5 went with an 8, it would add to 13, which would need a 4. If the 5 went with a 9, then it would add to 14, and it would need a 3. You know what was easier? Totally normal cat. If this was a 1, then there would be no 1 for the 8 arrow. That would be a lot easier. What is happening in this puzzle? I do not see a single thing. Oh, okay. Nice. What was nice? Yeah, this is true. You're distracting me. So that's why I'm not finishing the puzzle fast. Totally has nothing to do with the fact that I have no idea what to do. There is a 3 in here. If this is a 3, then this is not 3. And I thought that was okay because you could do 6 and 4. But is that actually false? Because then this would be a 5. This would be a 4. Does that even add to 12? That doesn't add to 12. Okay. This is why I had no idea, because this is probably the only deduction in the entire puzzle that you can even do. Like, so there has to be a 3 up here. Good night, Thomas. It's been great. Have a good night. That doesn't even do anything. Does that even do anything? I thought that was going to do everything, but it doesn't do anything, does it? It's not bifurcation. It's me thinking, yes, I knew this had to be a 3 in here, and I was just checking my understanding. Sorry, I'm trying to really focus and think, but I just can't figure out the next step to this. Like, it is really a 5, I think. No, it's okay. I do want to finish this, but it's really not like flowing right now for some reason. This is probably the most stuck I've ever been on a Qodec puzzle, I think. I don't want to pencil mark the whole grid. Because... So... There is a 5 in here, right? Oh, the other reason why this couldn't be a 3 was because that would put a 5 down here and this would be broken. Is there more of those sorts of things? 3 or 5? 5 can go with 8. Did I pencil mark these as if this is 6 or 7? Oh, wait. No, wait. Wait, there can be a 5 on here. But this can still be 2, because this is going to be 4 or 5. Yes, please give me a useful hint. I need to finish this, like, soon. Niveria, this is useless. Like, this can be almost anything. If this is a 2, this could be 4 or 5. If this is 7, this can add to 4. Like, what do you mean? There is a line summing to 11, but it has so many possibilities. No, it actually isn't real because I thought this was a 6, 7 when I was doing those. You actually pointed me that I have made a mistake. So this digit, if that goes on here, the other 3 cells add to 8. So if the other 3 cells add to 8, can row 1, column 1 be both 6 and 7? Obviously not, but what do you mean? Like, you're saying there has to be a 6 or 7 in one of these 2 cells? I mean, I know that. I was thinking about that, and then these cells would have to be 1, 2, or 3. But I'm not sure why that's important. To be honest. Well, if this is 6, 7, like this, then this has to be 2, 4, 5, doesn't it? Not B6. So if these both add to 15, then that's broken. So one of them has to add to 14, the other one has to add to 16, which means it has to be a 1, 3, which means this has to be 2, 4, 5. But then this would have to be row 8, column 3. Why? Why? Oh. Oh. Okay, just to explain that, so if these are both 6, 7s, and there's no 6, 7 here, this is the green 6, 7, which is with blue over here, which sums to 15. This is the yellow 6, 7, which is with red, which sums to 15, which means that both of these would have to be a 2. Andrew, this could be 4, 6, 1, 2. Oh no, then this would have no value. I see what you mean. Okay. Okay, so then we can remove the 5s from here. So you can put a 2. Why? If this is a 6, then these sum to 5, which could be either way. right? And if this is a 7, these sum to 4, so they don't have a 2. Pair, so one of the 6, 7 pairs with a, oh, right, okay. One of these is a 6, 7, which pairs with the 2. Right, okay. So then there's no 2 on here. So there's always a 1 because either it's 1, 3 or 1, 4. There's no 1 here. There has to be a 2 in one of these two cells. It's either a 2 here or a 2 here. Thirteen would need another 4. So 5 either goes with 4 or 3, the other digit that is not with a 1. Of course. Of course. So if there's oh wait, the 1s are aligning. So these are not 1s. So there is a 1 on here. Yeah, I just saw that. Yes, definitely a 5-star puzzle. So if this is 6, it has to be 2, 4, which would mean that that's a 2. Which means that the 4s would align, which would put a 4 there. Is that a 2, 4 is 6, right? And that would be 4, 5. Wait, 4, 5, and 9 does not work. Wait. If this feels like bifurcation, but I really don't care. So if this is 2, 4, the 2's align, so this is a 2. But then this can't be a 2, so it is a 4, and then the 4 is align, so there's no 4s there, so that has to be a 4. But then this has to be a 6, 7 with a 2, right? But then this has to be a 5, and then this will be 6 because it sums to 6. This will be the counterpart of 6, 9. But that's too much. That's 18. There's probably some easy way to see that. I accidentally hit Control N. What does row 4? Oh, these ones go in here. Oh, maybe that's the easier way to see that, okay. Could be trifurcation, yeah, okay. So this is a 7, which means that this is an 8, and we can just fill in a bunch of stuff. So 1, that's a 1, that's a 5. That's not a 5, or 1s, that's not a 4. I wouldn't usually, but, you know, time. This sums to 6, so it doesn't have a 3 on it. This is 8. Okay. Wait, isn't there definitely a 3? No, there's not. Try before you trifurcate. So this is either a 6, 7, or these could be 5s or 3, 4. But 5 with 8 goes with 3, or goes with 4. So this is this way. So then 3 is on this side of this box. 3 is on this side of this box. There's no 3 here, so there's no 4 here. No 2 or 5. This is a 3. It's not a 4 here, so this can't be a 5. That means that's not a 4. That's not a 5. That's a 5. That's a 4. That's a 5. That's a 2. Which means that this is not 2. So this is 5. So these two cells add to 8, so they have to be 3, 5. Which means that this is the 6, 7, and that is a 6, right? Okay, so that's a 6. That's a 7. That's a 5. That's a 4. This is a 2. These are not 4s. I mean, I don't think I would say that this solve is anywhere near the realm of impressive, but thank you. So this solve has been a bit pathetic, actually. So 1, 5 pair, and it's resolved. That's a 1, that's a 5. That resolves the 3 and the 1 over here. That resolves, oh. That's a 3. Sorry, I don't know why. Really, it is. Okay, interesting. Box 8 is finished. I'm sure it is. This is a 2, this is a 3, and this is a 6. That's a 3, and that's a 5, that's a 5, that's a 2, that's a 4, that's a 1. That 3 tells it that's a 4, that's a 1, that's a 1, that's a 4. Now we get a 3 and a 5 looking up here. That's going to resolve that this is a 5 and this is a 3. Finally, this is a 4, 4, 7, and 7 going. Oh, that was definitely a 5-star. Oh, nice. 7K puzzle pack. Well, everyone, thank you for watching and coming out and helping me with the end of that because I couldn't do it on my own. Because it's 27 degrees in this apartment. Yeah, so I'm going to be taking 2 weeks off to go on vacation to Mexico. So if so I won't be here, but I'm planning a few little things to release during that time, but it might not happen, so watch out for it, but it might not happen. But yeah, thanks everyone, and have a great rest of your day. See you later.